Hello there, and welcome to the Sleepy Astronomer. This is a quiet place where science becomes a lullaby, where the mysteries of the universe drift into stories that guide you gently into rest. Together, we will float among the stars and let the cosmos carry us into calm and wonder. So settle in, get comfortable, and let's begin tonight's journey. You rest in stillness, the kind of stillness that comes before sleep, and in that quiet you notice something vast. The universe itself seems to breathe, not with lungs, not with air, but with space, with distance, with time unfolding. You imagine it like a great ocean, silent and dark, where every galaxy is a small glowing boat drifting farther and farther across the waters. The expansion is soft, gentle, like the tide pulling ever outward. For a long time, people believed the universe was fixed and steady. The stars looked eternal, their places in the sky unchanged from one lifetime to the next. It was natural to imagine them pinned to some unshifting canvas. But the truth is more fluid, more alive. The universe does not sit still. It stretches, it expands, slowly, invisibly, yet without pause. You picture space itself as fabric. At first, you imagine it like cloth. But cloth tears if pulled too far. Instead, think of it as a balloon. On the surface of this balloon, tiny dots are galaxies. As the balloon swells, the dots do not move across the surface. The surface itself grows, and with it, the distance between the dots. No galaxy is flying away in the ordinary sense. Rather, the space between them grows. This balloon is not inflated by air, but by the very nature of the cosmos. Expansion is not an event, not a single explosion, but a continuing breath. Every second, the distances between galaxies stretch a little more. You're inside that breath, part of it, your entire world floating gently along. If you could watch from far outside, as though such a place existed, you would see galaxies drifting apart, each one like a lantern glowing in the deep dark, its light fading softly as distance increases. But from within, you feel only the gentle tug, the quiet drift, like being on a raft carried by a river you cannot see. This discovery, that the universe expands, was a revelation less than a century ago. Astronomers looked at light from distant galaxies and found it stretched. Like a violin string loosened, the pitch of the universe dropped. The colours shifted toward red, a sign that galaxies were moving farther away. What seemed fixed and eternal was alive with motion, slow but unstoppable. The idea is almost too large to grasp, yet it cradles you as you imagine it. You lie there in your bed, but your body is also lying within a galaxy that is itself moving, carried by expansion. The Milky Way is like one lantern among trillions, gently adrift on the sea of space-time. And you are here, small yet included, woven into this quiet unfolding. Notice how expansion is not loud. There is no roaring wind, no rushing of galaxies that you can feel on your skin. Instead, it is silent, like the slow widening of a dream. The distances grow invisibly, and yet the evidence lies in the light, in the way colours shift, in the way ancient stars whisper their stories across the void. You might wonder, if the universe is expanding, why do you not feel it here? Why is the space in your room not stretching, your body not expanding like a balloon? The answer rests in gravity. On small scales, gravity holds things together. Atoms hold you, gravity holds Earth, Earth holds the moon, and the sun holds its planets close. Expansion works on the grandest scales, where galaxies float so far apart that only the fabric of space itself guides them. Imagine a spider's web. On the strands, tiny droplets of dew cling tightly, unmoved by a breeze. Yet the web itself, delicate and vast, shifts with the wind. In the same way, galaxies cluster together. Stars cling to galaxies, but the cosmic web as a whole sways outward with the breath of expansion. This is the quiet breath of the cosmos, slow, steady, eternal. It has been happening since the very beginning, since the universe was born in a hot, dense state, and has continued ever since. Expansion is the rhythm of existence, the background music to all that happens in galaxies, stars, and planets. Close your eyes and let yourself imagine it. Imagine galaxies as glowing embers scattered across a black sea. They do not burn brighter or dimmer for your gaze, but they drift. The space between them grows so quietly you would never know if not for the whispers of light reaching your eyes. Expansion is patient, measured not in years but in billions of years. There is comfort in this slowness. The universe is not rushing, it's not hurried. Its breath is calm, measured, like your own. As you inhale and exhale, you mirror it. Your chest rises, falls. The cosmos stretches, rests. You are synchronized with it, a small rhythm within the great rhythm. And in this expansion there is story. Light carries that stretched into new colors as it travels, carrying messages from galaxies far away. Light becomes the traveler, the storyteller, the keeper of the universe's breath. You rest now, held in the thought that expansion is not something to fear. It is not destruction, but unfolding. Not chaos, but rhythm. You are not separate from it. You are inside it, always part of its widening embrace. The stars above, the galaxies beyond, the great dark that holds them all, they expand together, a symphony of space stretching into itself. And in this gentle motion there is both mystery and peace. As you drift towards sleep, you sense that the story is not complete. Expansion is only the beginning. For what carries this knowledge to you? What allows you to see the drift of galaxies, to measure the breadth of the universe? It is light. Light, travelling across impossible distances, whispering secrets from the past. You lie still, eyes closed, yet you see something. Not with sight, but with imagination. You see light, a soft glimmer, beginning in the heart of a distant star, rushing outward, escaping the furnace of nuclear fire. That single photon, a particle of light, begins a journey that may last millions, even billions of years before arriving at an eye like yours. Light does not age as you do. For a photon, the trip is timeless, though for you it stretches across unimaginable spans of time. It is as if each ray carries a memory, a story from the place and moment it was born. When you look at the night sky, you are not looking at the present. You are looking into the past. The star you see may no longer shine. It may have lived and died already, yet its light travels still, carrying its final song. Each star above you is both present and history, both now and then. Light is a messenger, a time traveller that allows you to witness what no other sense could ever reveal. Imagine the Milky Way. Its disk stretches across the sky, a hazy band of countless stars. The closest of them may send light only a few years old. The farthest, tens of thousands of years. You see them not as they are, but as they were when that light first set out, weaving its way through interstellar space. Now drift farther. Picture a galaxy millions of light years away. Its light began the journey long before humans walked the Earth, before animals roamed the continents, even before oceans settled into their beds. That light is only now arriving, slipping softly into your eyes, carrying the memory of a place impossibly far, and farther still, galaxies whose light is billions of years old. To look at them is to look nearly to the beginning, to when the universe itself was young. You cradle this thought gently, that in every faint glimmer lies a memory of the cosmos, a diary written in light. This is the gift of expansion. For as space stretches, it stretches light as well. Its colours shift, its wavelengths lengthen, sliding from blue to red, from visible to invisible. The universe paints with stretched light, giving astronomers their clues. Like reading wrinkles in paper or rings in a tree, they read the redshift of galaxies and know space itself is growing. You can picture it more simply. Imagine a drum beat. The beat begins steady, but as you walk away from the drummer, the rhythm seems to slow, the pitch falls. Not because the drum changes, but because your distance grows. In the same way, galaxies do not change their light, but expansion stretches it. Each photon lengthens like a note drawn out, softened across space. You let yourself feel the music of this. The night sky is a quiet symphony, with every star and galaxy playing a note delayed, softened, transformed by distance. You are not only listening with your eyes, You are listening with time itself. Light bends, too. It can curve around massive objects pulled by gravity's hand. Imagine a distant quasar, its light bent by the presence of a galaxy cluster. That bending creates echoes, duplicate images, as though you are seeing the same lamp reflected in many droplets of dew. Even in bending, light tells you something, that gravity shapes space, that mass and light dance together. And what patience light has. A photon may travel undisturbed for billions of years, untouched, until it finally meets an atom in your eye. That tiny collision, that instant of recognition, is the end of an epic journey. A story written across the ages completes itself in the space of a blink. You are part of this story too. When you were born, light from galaxies far away was already on its way here, carrying tales of events older than your world. When you breathe, when you blink, you are surrounded by light that has travelled for eons to reach this exact moment with you. There is comfort in this companionship. You are never alone beneath the stars. You are bathed in messages, in whispers from the farthest corners of existence. Some are ancient beyond comprehension, some only moments old, but all of them are gifts of presence, reminders that you are part of the great unfolding. Think of a candle in a dark room. Its flame flickers, and even when you close your eyes, the warmth remains, the memory of its glow stays with you. The universe is filled with such candles. Supernovae, stars that end their lives in fire, shine like beacons across billions of light years. Astronomers call them standard candles because they let us measure distances with their predictable brightness. By measuring them, scientists discovered something astonishing, that the universe's expansion is accelerating. Without light, this story would remain hidden. Without these candles, the secret would be locked away. Light alone makes the invisible visible. You let this thought rest within you. Light is not only illumination, it is memory, music, messenger, and measure. It carries the imprint of beginnings, of expansion, of the very structure of the cosmos. And still, there is more. Beyond stars and galaxies lies a faint glow, invisible to your eyes but detectable with instruments. It is the cosmic microwave background, the oldest light of all. Born when the universe was only 380,000 years old, it has travelled for nearly 14 billion years to reach us. Every direction you look, this ancient whisper surrounds you. It is the afterglow of the universe's birth stretched into microwaves by endless expansion. You may never see it with your naked eye, but you can feel the poetry of it. A baby picture of the universe wrapped around you like a soft blanket of light. Every inch of sky holds its memory, a reminder that the cosmos itself began in fire and has been stretching outward ever since. As you rest, you see yourself not only as a listener, but also as a witness. You are someone who has opened your eyes to the deep time of the cosmos. Light lets you do this. It bridges what no hand could touch, no foot could walk. It connects you to beginnings, to ends, to mysteries still unfolding. And now you let your breathing soften again. Each breath you take mirrors the journey of a photon. An inhale, a pause, an exhale, a movement through time. You're still yet carried. Silent, yet listening. Small, yet part of an infinite story told in glimmers. You begin to wonder, if light can travel so far, if it can carry so many secrets, then what happens to it as space stretches further and further? How does this stretching transform the colours of the sky, and what deeper messages lie hidden in that change? The thought lingers, gentle and unresolved. You follow it like a golden thread, stretching forward into the next chapter of your journey, a story written in colour in the universe's gentle redshift. You rest in the memory of light, the thought of ancient travellers crossing the dark. But now you begin to notice something subtler, something painted into the very fabric of those beams, a change in colour. Light does not always arrive as it began. It stretches, softens, drifts toward red. This is the red shift, the gentle fading of light as the universe expands. You can think of it as sound changing when it moves. When an ambulance passes, the siren's pitch drops as it rushes away. The sound waves stretch, the frequency lowers. Light behaves in the same way. When galaxies drift apart, the light they send lengthens, shifting toward the warmer end of the spectrum. Redshift is not a loss, but a transformation. What begins as blue or white softens, like a voice echoing in a canyon. its edges blurred. Each photon stretches, its rhythm slowed, carrying the unmistakable sign that space itself has grown during its journey. You imagine a violin string. Plucked tightly, it sings a high, bright note. Loosen it, and the note lowers, deepens, becomes more mellow. The universe does this to light. As space stretches, so do the notes of photons, tuned not by hands but by the expansion of existence itself. You look up at the stars and see them twinkling, but most are too close for you to notice their redshift. They are part of our galaxy, bound together by gravity. It is in the distant galaxies, the faint smudges of light that require a telescope's gaze, where the shift becomes visible. There, colours slide down the spectrum, soft and undeniable. Edwin Hubble was among the first to measure this in these 1920s. He discovered that almost every galaxy's light was redshifted, and the farther away the galaxy was, the greater its shift. Distance and redshift were linked like breath and heartbeat. This was not random, not chance. It was the signature of expansion. You imagine standing at the shore of a wide lake. Someone far away on the opposite bank throws pebbles into the water. The ripples spread outward, their crests growing farther apart as the waves travel. By the time they reach you, they are stretched, gentler, slower. Light is like that. By the time it arrives from distant galaxies, it has been stretched by the widening lake of space. The beauty of redshift lies not just in its proof of expansion, but in its softness. It is not violent. It does not tear or break. It is quiet and patient. Over billions of years, the colour slides, invisible to the human eye but visible to the careful instruments that watch the skies. Close your eyes and picture it. Imagine a galaxy sending out brilliant blue-white light. Across the eons, as space expands, the light stretches, sliding toward red, then infrared, then farther still, beyond what eyes can see. By the time it arrives, it is no longer what it was, but something new, carrying the memory of both its origin and its journey. This stretching is not about speed alone. The galaxies are not racing through space like cars down a highway. Instead, space itself is growing. The galaxies are carried with it, like dots on a balloon surface as it inflates. The dots do not move across the surface. The surface itself expands, and with it the distances. The redshift is not motion, but expansion written in colour. There is a rhythm to it. The farther the galaxy, the greater the shift. This law, called Hubble's law, is like a heartbeat of the cosmos. Expansion has a tempo, a steady measure, and astronomers hear it by listening to the red in the light. You too can imagine it, a cosmic metronome, clicking softly in the background of existence. What does this mean for you, lying quietly beneath the stars? It means that when you look into the sky, you are not only seeing beauty, you are seeing evidence. You are watching proof woven into the very beams of light. The night is not silent in its message. It speaks in colour, in wavelength, in softness and rounds. And yet the deeper message is more profound. If light stretches, if redshift grows with distance, then the universe has no fixed edge. It is expanding everywhere, all at once, in every direction. No place is the centre. Every point sees every other point moving away. It is a symmetry, a harmony, and a quality of perspective. You are not at the middle, but neither is any other. All places are woven into the same expanding breath. Hold this thought with tenderness, that the colours of the sky are not static, not permanent, but drifting, changing with time. Even now the universe is painting with softer hues, stretching its canvas wider with each moment. You are inside this painting, a brushstroke of matter upon the widening fabric, and still the question lingers. What drives this expansion? What unseen presence stretches the fabric so that every wavelength grows longer? You do not yet know. Scientists do not yet know, but redshift is the first clue, the first trail of breadcrumbs on the path to the mystery. You breathe slowly in and out. With each breath you mirror what the universe does with light. Stretching, lengthening, releasing. The cosmos is not rushing, it is patient, and in that patience lies comfort. When you think of redshift, do not imagine loss of brightness. Imagine transformation. Like autumn leaves fading from green to gold to red, the light changes as part of a cycle, as part of a journey. It is a reminder that everything changes with time, even the stars, even the sky. And in this thought you drift gently into wonder. For if the light changes, if the colours shift, then perhaps even the deepest constants are not so constant. Perhaps the laws of nature hold mysteries yet to be revealed. Your mind softens, but curiosity stays alive, a quiet flame. You wonder, who first imagined a balance in this expansion? Who first tried to explain why the universe stretches, and how? The thought pulls you forward gently into the next chapter, to the story of a great thinker, and the reluctant constant he once proposed. You rest now in the lingering glow of redshift. The universe has shown you its quiet stretching, its soft drift toward red. But the question remains, what force writes this story? Who first tried to capture it in symbols, in numbers, in thought? Your mind turns to a solitary figure, Albert Einstein, a thinker whose imagination reshaped how the universe is seen, a man who believed not only in logic but in beauty. His equations were not mere tools, they were like poems, like music written in the language of geometry. In the early 1900s, Einstein developed his great theory of general relativity. It was a way of describing gravity, not as an invisible pull, but as the bending of space and time. Imagine a fabric stretched taut. Place a heavy stone upon it and the fabric curves. Place a smaller pebble nearby and it rolls toward the stone, not because of an unseen force pulling, but because the fabric itself is curved. This was Einstein's vision, that planets and stars, even light itself, follow the curves carved into the fabric of space-time. The equations worked beautifully. They explained the orbit of Mercury, the bending of starlight during eclipses, the deep harmony of motion in the heavens. But they also whispered something troubling. If left alone, if nothing else acted, the universe in his equations would not sit still. Gravity, the constant attraction of mass, would pull everything together, slowly collapsing the cosmos inward. Einstein, like many of his time, believed the universe must be eternal, unchanging, balanced. A cosmos that simply is, a cosmos with no beginning, no end, no swelling, no shrinking, a stillness so vast it seemed natural. But his equations suggested otherwise. They seemed to imply that the universe could not remain steady. It must either expand outward or contract inward. The very mathematics resisted the vision of eternal stillness. So Einstein made a choice. Into his equations, he inserted an extra term, a gentle adjustment, the cosmological constant. It was like adding a counterweight to a scale. If gravity pulled the universe inward, this new constant would push outward, balancing the cosmos in perfect stillness. Neither collapse nor expansion, but a steady, eternal whole. You can imagine him at his desk, pen scratching paper, the quiet of his study filled with the hum of thought. The numbers danced, resisted, then settled into balance. Yes, this worked. With the cosmological constant, the universe stood firm. But was it real, or was it merely a patch, a device to protect an idea of stillness? Einstein himself seemed uncertain. He called it the lambda, a symbol of hidden pressure woven into the fabric of space. It was not a force from outside, not something new added to nature, but a possibility within the mathematics themselves. That space could resist collapse, that it could contain a pressure of its own. For a time, this vision of a static cosmos endured. Textbooks spoke of it, lectures taught it. The universe, held in perfect balance, seemed both elegant and eternal. And yet whispers of doubt grew louder. In the 1920s, other thinkers, like Alexander Friedman in Russia and Georges Lemaitre in Belgium, took Einstein's equations without the constant. They asked, what if the universe is not static? What if it is expanding? What if the redshift, faintly noticed, is not an anomaly but a truth? Their solutions revealed universes that grew, stretched, changed. At first, Einstein dismissed them. He resisted the thought. Expansion seemed untidy, disruptive, almost unsettling. The eternal cosmos felt safer, more beautiful. But then came Hubble. With his telescope and his careful measurements, the galaxy's redshifts were undeniable. The farther the galaxy, the greater the shift. The universe was not still. It was expanding, just as Friedman and Lemaitre had suggested. Einstein, faced with the evidence, abandoned his constant. He reportedly called it his greatest blunder, though historians debate the exact words. Still, the sentiment was clear. He regretted forcing stillness upon equations that naturally spoke of change, and yet, was it truly a blunder? You pause here, letting the thought ripple across your mind, for the cosmological constant, once discarded, has returned. Modern science has found that the universe's expansion is not slowing as gravity would suggest, but accelerating. Some unseen presence, some hidden pressure, pushes galaxies apart ever faster. And what name do scientists give to this mysterious force? Dark energy, a whisper perhaps, of Einstein's constant reborn. What is striking is the rhythm of this story, how even mistakes may become seeds of truth. Einstein sought stillness, and his constant was misplaced. Yet in time, the same idea would help explain acceleration, a deeper mystery than even expansion alone. Think of it like this: you plant a seed in the wrong place. It does not grow as you hoped. Years later, another gardener finds it, places it in better soil, and it blooms. The seed was not wrong, it was waiting for its season. Einstein's constant may have been like that. You breathe slowly, picturing the weight of such choices, how one mind, writing symbols on paper, could tilt the story of the universe. And yet, you also see the humility. Even the greatest thinkers must sometimes step aside, must allow new evidence to reshape their vision. For you, lying under the stars, the lesson is gentle and personal. The universe is not static. It changes, stretches, grows. So too does your understanding, so too does your life. The constant you thought would steady you may one day become a seed for something greater. You let this truth soften you, that uncertainty is not failure, that even in doubt, even in reluctance, wisdom grows. And as you drift deeper, you wonder, if Einstein gave us the vision of relativity, and if redshift revealed expansion, then what comes next? How do we measure this vast growth, this stretching of space? How do we place numbers upon infinity? The thought lingers like a faint echo pulling you onward, toward rulers not of wood or metal but of light itself, measures stretched across galaxies, and the gentle laws that reveal the universe's size. You lie in the calm of the night, still carrying the thought of Einstein's constant. You feel how ideas stretch, how equations can shape the way you see the cosmos, and yet a question lingers like a star waiting to be noticed. How do you measure something as vast as expansion? How do you place numbers on a sky that has no edge? The answer begins not with metal rulers or ticking clocks, but with light. Light becomes the yardstick, the gentle measure of space. Every beam, every pulse, every flicker tells a story. Astronomers long ago realized that if you know how bright something truly is, and you see how dim it appears from Earth, you can calculate its distance. It is like watching a lantern across a lake. If you know the lantern's flame, you can tell how far it must be by how faintly it glows. This is the essence of a standard candle, an object whose brightness is steady and known, a cosmic lantern against the dark. One of the first candles discovered were Cepheid variable stars. These are stars that pulse, brightening and dimming in a steady rhythm. Like a heart, their light beats with a pattern. Henrietta Swan Leavitt, an astronomer in the early 1900s, studied them carefully. She found that the longer the star's period of pulsing, the brighter it truly was. The rhythm itself revealed the light's strength. Imagine holding a drum and listening not just to its sound, but to the space between beats. Longer pauses meant louder drums, smaller pauses meant softer ones. The Cepheids worked this way. By timing their rhythm, astronomers could know their true brightness, and by comparing it to their faintness, they could measure distance. This was revolutionary. For the first time, astronomers could reach beyond the edges of our own galaxy. They could measure other galaxies, faint spirals and smudges, and prove that they lay far beyond the Milky Way. The universe expanded not just in space, but in mind. And yet, Cepheids were only the beginning. Another kind of candle flickers across the cosmos, the light of a dying star, a Type 1, a supernova. These explosions occur when a white dwarf star, small but heavy, draws matter from a companion until it cannot bear the weight. Then in a single burst it ignites, shining with a brightness so powerful it can outshine entire galaxies for weeks. The beauty of these supernovae is their uniformity. They all ignite in nearly the same way, reaching almost the same peak brightness. Like identical lighthouses on different shores, They beam with reliable power. By measuring how bright they appear to us, astronomers can know exactly how far they must be. It was with these cosmic candles that scientists discovered the universe's expansion was accelerating. By comparing distances with redshifts, they found galaxies were not only receding, but receding faster with time. Dark energy, the whisper of Einstein's constant, entered the story again. But light does more than flicker. It also bends. Another tool of measurement comes from gravitational lensing. Massive galaxies and clusters act like lenses, bending and magnifying light from even more distant objects behind them. By studying the bending, astronomers can estimate distances, like reading ripples on a pond to judge the depth of the stone that caused them. And there is yet another measure, a grander one still, the cosmic microwave background, the faint afterglow of the Big Bang. This background light fills all of space, stretched now into microwaves by billions of years of expansion. Within its gentle hum are patterns, tiny ripples in temperature and density that serve as a kind of cosmic ruler. By studying those ripples, astronomers can measure the universe's size, its age, and its rate of expansion. So many rulers, all woven of light, Cepheids pulsing, supernovae exploding, galaxies bending, ancient radiation humming, each one like a different note in the same symphony, all pointing to the same truth. The universe is stretching. Pause here and notice the rhythm. Notice how science does not rush. Each discovery, like each breath, builds upon the last. First came Cepheids, then supernovae, then the cosmic microwave background. The tools grew finer, but always the method was the same. Listen to light. You breathe in, feeling yourself as part of this listening. Your own eyes, sensitive to faint starlight, are like small instruments tuned to the cosmos. You may not see Cepheids or supernovae from your window, but the principle is the same. You are touched by beams that travelled unimaginable distances, carrying with them the quiet story of space's growth. And here lies a deeper reflection. To measure expansion is not only to know the universe, it is also to feel humility. You are small, and yet you hold a ruler made of light itself. You cannot stretch your hand across galaxies, but you can listen to their glow, to their pulses, to their explosions. Imagine standing in a great hall with no walls, no ceiling. To measure it, you cannot use steps. But if someone claps, and you hear the echoes returning softer, you begin to know the hall's vastness. So too with the cosmos. Each star's brightness, each galaxy's redshift, is an echo, and from those echoes, you build a sense of space without end. And yet, there is still mystery. Measurements differ slightly. Some methods give a faster expansion rate, others slower. Astronomers debate this quietly, like musicians tuning their instruments before a concert. Why the difference? Is it a sign of hidden physics? Of something new waiting to be found? Or is it simply the difficulty of measuring with such precision? The universe holds its secrets with patience. It reveals them slowly, flicker by flicker, rhythm by rhythm. And you, listening now, are part of that long unfolding. As your breath deepens, you feel the comfort of this thought, that even if the answers are incomplete, the act of measuring is itself a kind of wonder. To reach across the dark with light, to place rulers of brightness upon the sky, is to make the infinite feel touchable. And yet, as you drift further, you begin to ask what lies behind the expansion. What energy, what presence fills the cosmos, pushing it ever outward, ever faster? What is this dark energy, this silent current, that no ruler can yet fully measure? The question hangs in the air, gentle but unresolved, drawing you softly forward, toward the mystery of the unseen, toward the whisper of a force without a name, toward the dark energy itself. You rest in the soft glow of memory, still hearing the echoes of light used to measure distance, still seeing the flicker of stars and the bursting of supernovae. But the more you think of expansion, the more a new question unfolds. Expansion is not slowing down, as gravity would suggest. Instead, it is quickening, as though something invisible breathes outward through the very fabric of space. This something is called dark energy. Dark because it cannot be seen. Energy because it has effect, power, influence. It is not light, Not matter, not the familiar particles that build your body or the stars. It is a quiet presence woven into space itself, a whisper that pushes galaxies apart. Close your eyes and picture a sailboat upon a still sea. The boat sits quietly until a breeze rises. You cannot see the breeze, but you see its work. The sail billows, the boat begins to drift. The water ripples in its wake. Dark energy is like that unseen breeze, filling the sails of galaxies, urging them apart. In the late 1990s, two teams of astronomers used Type Ia supernovae, so the cosmic candles, to study how fast the universe was expanding. They expected to find slowing, as though the cosmos, born from a great explosion, was gradually yielding to gravity's pull, but what they found was the opposite. The expansion was speeding up. Galaxies were not only receding, they were receding faster with time. It was as though someone had placed a hand upon the universe and given it a gentle push outward. This revelation reshaped cosmology. Suddenly the universe was not only expanding but accelerating. And the cause, though invisible, required a name. Thus dark energy entered the language of science, a placeholder for a mystery too large to move. Fine, you breathe slowly, letting the weight of this mystery settle gently. Nearly 70% of the universe, scientists say, is this dark energy. Imagine that. Most of what exists is invisible, untouchable, undetectable except by its effect. The stars you see, the galaxies you know, the planets and matter, they make up less than 5%. Dark matter fills another quarter, but dark energy is the greatest share. You live in a universe dominated by the unseen. And yet, despite its dominance, no one knows what dark energy truly is. Some think it may be connected to Einstein's cosmological constant, the lambda he once inserted reluctantly into his equations. Perhaps space itself has energy, a kind of pressure that pushes outward. As the universe grows, the energy does not dilute, but continues, steady and unyielding. Others imagine it differently, as a changing field, a dynamic force that shifts with time. They call it quintessence, a word that once meant the fifth element beyond earth, air, fire and water. Something subtle, something pervasive, something not fixed but alive with variation. Still others wonder if our understanding of gravity itself is incomplete. Maybe what we call dark energy is not a separate force, but a sign that Einstein's equations need further expansion, further evolution. You can think of it as standing in a room with a locked door. You hear wind whistling through, feel pressure against the walls but cannot see the source. The door is closed, the mystery hidden, yet you know something is there by the way it moves everything else. What makes this whisper so profound is not only its existence but its consequence. If dark energy continues, galaxies will drift farther and farther apart, stars will fade from one another's skies, the universe will become lonelier, quieter, more diffuse. Billions of years from now, future observers may see only their own galaxy, with no hint of the wider cosmos that once stretched around them. Pause here and breathe with that thought. Expansion is not a rush, not a storm. It is slow, patient, gentle across billions of years. You need not fear it. It is not violence but drift, like ink slowly spreading through water. And yet, the very slowness makes it haunting. A universe where dark energy rules is a universe destined for distance, for dimming, for silence. But in the present moment, dark energy is not a weight but a wonder. It reminds you that the universe is more mysterious than any one model, more complex than any single idea. It whispers that certainty is never final, that discovery is always waiting. Think of how often the unseen shapes your own life. You cannot see air, yet you breathe it. You cannot see time, yet you move through it. You cannot see gravity, yet you feel its hold with every step. Dark energy belongs to this family of invisibles, the forces that cradle existence in silence. And perhaps, in this mystery, there is comfort. For if so much of the universe is hidden, then you too can hold mysteries within yourself. You too can carry unseen strengths, unseen possibilities. You are not defined by only what can be measured. Astronomers listen, watch, calculate, but the whisper continues. Each new telescope, each new observation is like pressing your ear against the door of the cosmos, hearing faint music beyond. One day the door may open, one day the whisper may become a voice. Until then, you rest in the wonder of not knowing. Let this not knowing soothe you. The need for answers is softened here, replaced by the rhythm of curiosity, the calm acceptance that some mysteries take lifetimes to unfold. And yet, you feel a gentle tug forward. If dark energy is the whisper, then perhaps light carries another message, not only of distances, but of time itself. If light stretches, if it redshifts, then perhaps it is also a messenger of age, of beginnings, of the first moments of the cosmos. You linger with this thought, letting it expand softly in your mind. What if light could show you not only where things are, but when they were? What if every photon is not just a ruler of space, but a clock of time? And so, as you drift toward rest, you carry the whisper with you. The whisper of dark energy, unseen but present, quiet but powerful. A force that shapes galaxies, and yet leaves you with a question unanswered. The question flows like a current, drawing you gently into the next reflection, into the light of ancient beginnings, into the story written in the afterglow of creation, into the cosmic microwave background, the universe's earliest memory. You're still holding the whisper of dark energy, its unseen push spreading galaxies apart. But before you drift farther into that mystery, another light begins to call you back. Back not just in space, but in time. It is older than stars, older than galaxies, older even than the very shapes of atoms. It is the universe's first memory, the cosmic microwave background. Close your eyes and imagine the universe as newborn. It is hot, dense, and filled with a glowing fog of light and particles. In those first moments, photons, particles of light, could not travel freely. They scattered endlessly, bouncing off electrons unable to move far. The cosmos was like a cloudy sky, thick with haze. But then, about 380,000 years after the Big Bang, something changed. The universe had cooled enough for protons and electrons to join together and form neutral atoms. With fewer free charges to scatter them, photons were released. At last, light could travel unhindered. That first free light has never stopped travelling. It has stretched, softened, shifted through billions of years of expansion. What was once a brilliant glow of fire is now a gentle bath of microwaves, cold and faint but everywhere. That is the afterglow of creation, the cosmic microwave background, or CMB. It surrounds you now. It passes through you as you breathe. Every direction you look, it hums with quiet consistency. You cannot see it with your eyes, but special instruments can. If your television were tuned to static in the past, a fraction of that fuzz came from this cosmic echo. The universe's childhood speaks even through the simplest machines. Pause and picture it. Imagine the sky, not as stars or galaxies, but as a map of faint ripples in temperature, mere millionths of a degree. These ripples are the fingerprints of the early universe. They show where matter was slightly denser, where gravity began to gather clouds, where galaxies would one day form. From these seeds, entire clusters of stars would grow. The CMB is like a baby's first photograph. Not sharp, not detailed, but precious. It shows the universe in its infancy, when it was only a few 100,000 years old. To see it is to gaze upon the beginning of structure itself. In 1965, two engineers, Arno Penzias and Robert Wilson, stumbled upon this glow. They were testing a radio antenna in New Jersey, and no matter what they did, they kept hearing a faint hiss. They cleaned the antenna, even brushed away nesting pigeons, but the hiss remained. At last, they realized it was not noise from the machine at all. It was the universe itself, whispering across time. Since then, satellites have mapped this glow in exquisite detail: COBE, WMAP, Planck. Each mission sharpened the picture, refining the temperature ripples, the tiny variations that carry profound meaning. From the CMB, astronomers learned the age of the universe in about 13.8 billion years. They measured its composition, how much matter, how much dark matter, how much dark energy. They traced its curvature, its geometry, its fate, all from a faint afterglow stretched into microwaves. Think of the poetry of that. A whisper from nearly 14 billion years ago, still audible today. A memory so ancient yet carried faithfully across expanding space, across galaxies, across time until it reaches you. You may wonder why this light still exists, why it has not vanished. The answer lies in expansion itself. The photons released at that early time continue their journey because space has no walls. There is nothing to absorb them fully, no boundary to stop their flight. They stretch, cool, shift, but they persist. They are the most patient travellers imaginable. Imagine carrying a message in a bottle, casting it into an infinite sea. The bottle never sinks, never shatters. It drifts endlessly, until one day it washes up at your feet. The CMB is like that message, arriving to you after billions of years of cosmic drifting. Let this thought calm you. You're connected not only to the stars above, but to the very beginning. The light that fills the universe is the same light that marked its first breath. You are in this way holding hands with creation itself. And yet the afterglow is not just history, it is a map, a guide, a foundation. The tiny ripples recorded in it explain why galaxies cluster, why cosmic webs stretch, why some regions of space are rich in stars while others are vast voids. The universe we see today is the grown child of those ripples, matured but recognizable. Pause again and breathe slowly. You are looking at your own origin too, for everything around you, your body, the air, the earth, traces its roots to those same ripples, those same early fluctuations in the afterglow. Without them, there would be no galaxies, no stars, no planets, no life. The CMB tells you that the universe is not only vast but structured. It is not chaos, but patterned. Even in its infancy, it carried within it the seeds of order, the whisper of design written in physics and chance. You rest now in this comfort, that the beginning was not empty but full of potential, and yet the CMB also deepens the mystery. For if you can see the afterglow, you can measure expansion, you can map the ripples, then you must also ask, what came before this light? What happened in those first fractions of a second, when the universe was smaller than an atom, hotter than any star? This question beckons like a horizon. It invites you to look deeper into the hidden instant called inflation, when the universe may have grown faster than light itself, swelling in a heartbeat from subatomic to cosmic scales. You're not there yet, but you feel its pull. The afterglow points backward, a breadcrumb trail leading into the unknown. So as you close your eyes tonight, let the glow wrap around you like a blanket. The afterglow of creation is not gone. It is with you now, a faint hum of the universe's first light, still whispering, still present, still shining invisibly through the dark. And as you breathe, you carry the thought forward, toward the question of what came before, toward the swelling of the first instant, toward the great mystery of cosmic inflation. You're still wrapped in the afterglow of creation, the faint hum of the cosmic microwave background. But even as you listen, the light is not the beginning. It is only the first photograph, the first memory the universe allows you to see. Behind that glow lies a hidden moment, a heartbeat of time so brief, so powerful that it shaped everything to come. This is the story of inflation, the swelling of the first instant. Close your eyes and imagine the universe in its earliest fraction of a second. The numbers almost lose meaning, a trillionth of a trillionth of a trillionth of a second. Time so small it slips between your fingers like mist. And yet in that instant, the universe grew from smaller than a subatomic particle to larger than a galaxy. It is as though the cosmos took a single breath, and in that breath, space itself expanded faster than light. You might wonder, how can anything be faster than light? The answer rests in the difference between moving through space and the stretching of space itself. Nothing can travel through space faster than light, but space can grow, stretch, swell at any rate, with no limit. Inflation was not a journey through space. It was the creation of space. Picture a balloon, soft and small, its surface almost invisible. Now, in a heartbeat, the balloon swells. Patterns of colour printed on it stretch outward, smoothed, spread. Tiny wrinkles vanish. What was once close together becomes far apart. The balloon is the universe, and its sudden swelling is inflation. In this expansion, irregularities smoothed out, hot and cold blended, matter spread evenly. Like water settling in a still pond, the universe became uniform, calm, balanced. Without inflation, the cosmos would be messy, clumpy, too uneven to form the graceful galaxies we see today. Inflation was the great harmonizer, and yet, not everything smoothed completely. Tiny quantum fluctuations, little ripples of energy that flickered in and out of existence, were stretched by inflation too. These ripples became the seeds of galaxies. Imagine the smallest quiver of a violin string amplified until it fills a concert hall. Quantum tremors, magnified by cosmic expansion, wrote the blueprint for stars, clusters, and the web of galaxies. Pause here and let that sink in. Everything you see tonight, every star overhead, every planet beneath those stars, every atom in your body, began as a fluctuation, a tremble of quantum foam stretched in the swelling of the first instant. You're built from whispers of uncertainty, magnified to cosmic scales. For a long time, inflation was only an idea, a bold proposal. But as scientists studied the afterglow, they found patterns that matched its predictions. The smoothness of the cosmic microwave background, its faint ripples, its geometry, all of these spoke in unison. Yes, inflation happened, and so, when you gaze at the sky, you're looking not only at stars and galaxies, but at the echo of a swelling so quick, so total it reshaped existence. Let your mind wander deeper. Inflation did not just stretch space, it may also explain why the universe looks the same in every direction. Without it, distant galaxies would never have had time to exchange heat, light, or information. They would be strangers, disconnected, but inflation gave them a shared origin, a common beginning. It is as though you're standing in a vast meadow of flowers. Without inflation, each patch would bloom differently, separate, chaotic. With inflation, the meadow shares a rhythm, a harmony, as though one unseen hand brushed evenly across the field. And there is more. Inflation may explain why the universe is so flat. If space were curved like a sphere or a saddle, light would bend and the afterglow would reveal it. But instead, the universe appears flat across unimaginable distances. Inflation stretched it so enormously that any curvature was ironed smooth, like wrinkles pressed from cloth. You breathe slowly, letting this image fill you. The universe is fabric, pulled so wide, so taut that it feels flat beneath your gaze. But even as you rest in this image, a quiet question arises. What drove inflation? What force swelled the universe so quickly, then stopped so suddenly? Physicists speak of an inflaton field, a sea of energy that once filled space. Like a ball rolling down a hill, it released its stored energy in a rush, expanding the universe in an instant. When the ball settled at the bottom, inflation ended, and the universe continued its slower, steadier expansion. Though poetic, this picture is only a model, a metaphor. The true nature of inflation remains hidden, wrapped in mystery, and so you find yourself in a paradox. Inflation explains so much. The smoothness, the flatness, the seeds of galaxies, yet it also opens the deepest questions. Did inflation happen once, or could it happen many times? Could our universe be one bubble in a vast foam, each bubble born from its own swelling? Could we live in just one of countless inflating worlds? You do not need to answer tonight. You only need to feel the wonder, the vastness of possibility, the quiet awe of beginnings too quick for the eye yet written across the stars. For even though inflation lasted only a heartbeat, its effects are eternal. You see them every time you look at the sky. You feel them every time you breathe. Your very being is stitched into the fabric inflation stretched. Rest in that thought, that you're not separate from the universe's first instant, but a continuation of it. You're the living echo of that swelling. And yet, as inflation ends, a new chapter begins. The hot, dense universe is now filled with matter and radiation, with particles colliding, combining, separating. It is an ocean of fire, glowing and fierce, ready to give birth to the first elements. You're carried forward now, out of the hidden instant into the furnace of creation. The question lingers softly in your mind, leading you onward. If the universe swelled in a heartbeat, what arose in the fire that followed? What elements first lit the path toward stars, toward planets, toward life? You drift gently out of the swelling of the first instant. Inflation fades, leaving behind a universe stretched wide, smooth, and filled with energy. Now, in this newborn cosmos, time begins to slow into moments you can almost count. Seconds pass, minutes follow, The furnace of creation is burning, and in its heat the first elements are forged. The scene before you is a sea of fire. Temperatures are unimaginable. Trillions of degrees in the first moments, cooling steadily as space expands. In this ocean of energy, particles flicker into being. Quarks, tiny building blocks of matter, appear, collide and join together. They form protons and neutrons, the cause of atoms to come. It is less than 1 second after the beginning, yet already the foundation of the material universe is being laid. Imagine sparks flying in all directions, each spark a proton or neutron, destined to shape worlds. In the first 3 minutes, the universe becomes a cauldron of nuclear reactions. Protons fuse with neutrons, forming the simplest nuclei. Hydrogen emerges, the lightest element, 1 proton standing alone. Helium forms 2 protons and 2 neutrons, bound in a tight embrace. In smaller traces, lithium appears, delicate and rare. These are the first elements, not metals, not complex atoms, but simple, pure and essential. The cosmos does not yet know of carbon, oxygen or iron. Those will come later, in the hearts of stars. But hydrogen and helium are the beginning, the primary fuel of the universe. Picture hydrogen as a single note, soft and clear. Helium is the harmony that joins it, stable and smooth. Together they form the first music of matter. The universe is a young symphony playing its opening chords. As minutes stretch into hours, the fire cools too much for further fusion. The great furnace shuts down. No new elements can form. The universe has frozen its first recipe, about 75% hydrogen, 25% helium, and just traces of lithium. That mixture will define everything that follows. Pause and feel the weight of this. The air you breathe, the stars you see, the oceans on Earth. All of them began with this ratio, this simple balance set in the first minutes. You are living within the memory of that early chemistry. The process has a name, Big Bang nucleosynthesis. Nucleosynthesis means the making of nuclei, the binding of protons and neutrons into atoms. It is not a human forge, not a laboratory experiment, but a cosmic act of creation. The whole universe was the furnace, every corner aflame, every region alive with collisions and bonds. You may wonder how we know this story. The answer lies in observation. When astronomers look at distant galaxies, they measure the light of stars and gas clouds. That light reveals chemical fingerprints, showing how much hydrogen and helium exist. The ratios match perfectly with the predictions of Big Bang nucleosynthesis. The theory and the sky sing the same song, and so, with confidence we say, this is how it began. These were the first bricks. Hydrogen, so light, so simple, will gather into clouds. Those clouds will collapse into stars. In the furnace of those stars, heavier elements will be born: carbon, oxygen, nitrogen, iron. Without hydrogen, there would be no stars to shine. Without helium, stars would lack the balance they need to burn steadily. Think of it this way. Hydrogen is the fuel, helium the stabilizer. Together they give stars their rhythm, their longevity, their gentle persistence across billions of years. Without this balance, stars would flare too quickly or fail to shine at all. The universe's fire would fade before it began. But the recipe was just right. Close your eyes and imagine yourself as part of this timeline. The hydrogen in the water you drink was born in those first minutes. The helium that fills balloons on Earth began as nuclei in that same fire. You carry in your body atoms forged when the universe was only 3 minutes old. You're a living continuation of that furnace, breathing its ancient breath. The thought is humbling, but also comforting. You're not separate from the universe's birth. You're woven into it, as surely as stars and galaxies are. Yet in this young universe, things remain simple. There are no stars yet, no planets, no galaxies. Only vast clouds of hydrogen and helium spread thinly across expanding space. The first elements are the script, but the play has not yet begun. You linger in this calm, knowing the drama will come. Gravity will gather these gases into clumps, into stars that ignite and burn. Within those stars, new elements will form, creating the chemistry of life. But here, at the beginning, all is potential. The building blocks are ready, waiting. Breathe slowly and imagine the silence of that moment. No starlight pierces the darkness. No galaxies swirl in the distance. Only the soft glow of the afterglow remains, wrapped around clouds of hydrogen and helium. The universe is pregnant with promise, but still in its infancy. Even so, the seeds of everything are here. The water in rivers, the oxygen in lungs, the iron in blood. All of these depend on hydrogen and helium's first existence. Without them, there would be no chemistry of life, no poetry of matter, no story to tell. Pause again and feel gratitude. Gratitude for a universe that began with fire, cooled with care, and left behind the simplest, most essential elements. But just as you rest in this thought, another question arises. If the universe is filled with hydrogen and helium, how will these gases come together? How will the first stars be born? This question pulls you gently forward. You see the early elements as clouds, vast and diffuse. They wait suspended until a new force begins to work. A force you already know, one that shapes your own body and holds the earth beneath your feet. That force is gravity. And so, as you drift at the edge of sleep, you carry this quiet thought. From fire came hydrogen and helium. From hydrogen and helium will come stars, and in stars the universe will take its next step toward light. You rest in the hush of hydrogen and helium, the first elements forged in the fire of the newborn universe. The cosmos is vast, expanding and cooling. There is no starlight yet, only darkness, and the faint afterglow stretched into microwaves. You are floating in a universe waiting for its next chapter. Then slowly, a new force takes the stage, gravity. Gravity is quiet but unrelenting. It has no sound, no colour, no edges, and yet it is everywhere, pulling gently, gathering matter together. Over millions of years, hydrogen and helium clouds begin to drift inward, attracted to their own collective weight. Tiny fluctuations, born during inflation and preserved in the cosmic afterglow, now grow under gravity's guidance. Imagine the universe as a vast ocean. In that ocean ripples form, those ripples deepen into waves, and the waves collapse into swirling eddies. Each eddy gathers gas, growing denser, hotter, tighter. At first, the collapse is slow, patient. Hydrogen atoms move closer together, their dance increasingly confined. But gravity does not rest. The collapse continues, squeezing atoms until their cores are pressed into intimacy. The temperature rises, the pressure mounts, the cloud glows with invisible heat. Then, in a moment both inevitable and miraculous, the first fusion begins. Hydrogen nuclei collide and merge, forming helium. The reaction releases energy, and that energy shines as light. The darkness of the universe is broken by the first stars. Pause and feel the weight of this moment. For hundreds of millions of years, the cosmos has been dark, silent, expanding. Now, with the ignition of the first stars, it awakens. Starlight spills into the void, flooding it with brilliance. These stars are not like the stars you know today. They are enormous, far larger than your sun. Some may be hundreds of times more massive. They burn hot and fast, brilliant blue-white flames in the darkness. Their lives are short, measured not in billions of years like the sun, but in mere millions. Yet their impact is profound. These first stars are called population 3 stars. They are made almost entirely of hydrogen and helium, pure children of the Big Bang. With no heavier elements to cool their gas, they collapse into massive forms. Their cores blaze with nuclear reactions, forging the first new elements beyond helium. Inside their fiery hearts, carbon, oxygen, nitrogen, and iron are born. These are the elements of life, the building blocks of planets, oceans, and breath. And when these giant stars reach the end of their brief lives, they explode. Their deaths are supernovae, titanic outbursts scattering heavy elements into space. The universe, once simple, now becomes rich. The ashes of the first stars seed the cosmos with the chemistry of creation. Breathe slowly and let this thought sink in. Without those first stars, there would be no you. The carbon in your cells, the oxygen in your lungs, the calcium in your bones, all were forged in stars and spread by their deaths. You are stardust, recycled matter from ancient explosions. But before their deaths, the first stars also brought light. They ended the cosmic dark ages, the long era when the universe was filled only with neutral gas and faint afterglow. With starlight came ionization, the breaking apart of atoms. The universe became transparent once again, filled with photons travelling freely. It was as though a cosmic dawn had risen. Imagine standing on the edge of a silent sea at night. For hours, the water is dark. calm, featureless. Then one by one lanterns ignite on the horizon. Their glow spreads across the waves, revealing shapes and textures you could not see before. This was the dawn of stars, and with them came structure. The first stars gathered in groups, drawn together by gravity into clusters. These clusters merged, becoming the seeds of galaxies. What began as isolated lights grew into vast swirls, spirals and ellipses, the galaxies that would one day fill the universe. You can almost picture it. The cosmos as a canvas, once dark and blank, now painted with the brushstrokes of starlight. Galaxies as great strokes of colour, glowing arcs across the sky. The universe transformed from silence into song. And yet, the song of the first stars was fleeting. Their lives ended quickly. In explosions so powerful they left behind black holes. Some of these black holes grew by swallowing gas and stars, becoming the supermassive black holes that anchor galaxies today. Even in death, the first stars shape the future. Pause again and consider the rhythm of this story. Simplicity gives way to complexity. Darkness yields to light. Fire creates, then destroys, and through destruction builds anew. The universe is not static, but ever becoming. The ignition of the first stars also brought colour to existence. Before them, the universe had no visible light, only microwaves and faint infrared glows. With stars, the cosmos shimmered with blues and whites, later with yellows and reds. The palette of creation expanded. Your eyes, attuned to starlight, are inheritors of this gift. The very ability to see is tied to the light those first stars unleashed. Without them, there would be no sight, no vision, no colours to dream upon. And so you rest in gratitude, knowing that stars are not distant strangers but your ancestors. Their light continues to travel, their elements continue to live within you. The first stars also remind you of impermanence. They blazed brightly but briefly. They remind you that beauty need not last forever to matter. A single flame, even if short-lived, can illuminate eternity. This meditation leaves you calm, cradled in the vastness of time. You feel the warmth of those first fires, even now, as you breathe in the present. And yet your mind drifts onward. If stars were born, galaxies must follow. The universe, once dotted with scattered clusters, will weave them together into great cities of light. You are drawn toward that vision, the gathering of stars into galaxies, the architecture of the cosmos taking shape. You rest tonight with the lingering glow of the first stars, their ignition still echoing in your imagination, their death scattering seeds of life into the dark. And as your breathing slows, one question carries you forward. If stars are the sparks, what grand patterns emerge when billions of sparks gather as one? You rest in the glow of the first stars, their brief lives blazing and fading, scattering seeds of heavier elements into the dark. Yet stars alone are only sparks. To become something greater, they must gather, drawn together by the quiet hand of gravity. This is how galaxies are born. Close your eyes and imagine gravity as an artist. Its brush is invisible, but its strokes are firm. It pulls stars toward one another, guiding them into swirls, clusters, and arcs. What begins as scattered lights across the void becomes patterned, structured, woven into luminous forms. At first, these galaxies are small, no larger than a few star clusters. They are irregular, chaotic, shaped by chance. But as time stretches into hundreds of millions of years, these infant galaxies merge. They collide, blend, and reshape, becoming larger and more majestic. The universe, once dark, now begins to glow with galactic fire. Picture the night sky not as you see it now, but as it was then. No Milky Way, no familiar constellations, but countless young galaxies shining in every direction. Each one a city of stars, each one a growing community of light. The earliest galaxies are made mostly of hydrogen and helium, their stars massive and short-lived. With every generation, however, supernovae enrich them with heavier elements. Carbon, oxygen, nitrogen, iron, these spread like nutrients, preparing the universe for future worlds. Galaxies are not only collections of stars, they are forges of chemistry, nurseries of possibility. You might wonder how many galaxies exist. Today, astronomers estimate at least 2 trillion in the observable universe. 2 trillion cities of stars, each with billions of suns, each with the chance of planets and perhaps even life. The mind drifts into awe at such numbers, yet the story began simply, with gravity drawing the first stars together. Pause for a moment and feel the intimacy of this truth. The Milky Way itself, the galaxy you call home, was once a small and fragile collection of stars merging and colliding, growing into the great spiral you see today. Your night sky is the descendant of those early galactic gatherings. Galaxies come in many shapes. Some are spirals, graceful arms winding around bright centers like whirlpools of light. Others are ellipticals, rounded and smooth, filled with older stars. Some remain irregular, chaotic reminders of collisions and chance. Together they form a cosmic menagerie, diverse and beautiful. Yet galaxies do not float alone. They cluster in groups, held together by gravity. These groups form superclusters, and superclusters weave into immense filaments stretching across space. Between them lie vast voids, empty and silent. The universe, on the larger scales, is a cosmic web, galaxies strung like pearls along invisible threads, woven into patterns larger than imagination. And you are part of this web. The Milky Way belongs to the local group, a family of about 50 galaxies. Together, the local group is pulled toward the Virgo cluster, which itself is part of the Laniakea supercluster, a grand river of galaxies flowing across hundreds of millions of light years. It is humbling to realize that even galaxies are not solitary. Just as stars gather into galaxies gather into webs. The universe repeats its rhythm, unity born from many, patterns from chaos, structure from silence. But what holds galaxies together? Gravity again plays its role, yet there is more. Astronomers discovered that the visible matter, stars, gas, dust, is not enough to explain the strength of galactic bonds. Something unseen, something mysterious outweighs the visible. They call it dark matter. Dark matter does not shine, does not emit or absorb light, yet its gravity sculpts galaxies. It forms invisible halos around them, cradling stars in place. Without dark matter, galaxies would fly apart, their stars scattered into space. With dark matter, galaxies remain stable, long-lived, capable of creating new generations of stars. Think of dark matter as the silent framework of the universe, like the bones of a body. You cannot see it, but without it, structure would collapse. It is the hidden skeleton upon which galaxies are built. And so, as you gaze at the stars tonight, know that you are looking at more than light. You are looking at shapes held by darkness, patterns carved by the unseen. Pause again and breathe slowly. Feel the comfort of belonging to something vast, something structured. The galaxy above is not random. It is the result of countless forces, countless gatherings, countless mergers across billions of years. The Milky Way itself tells this story. Its spiral arms hold hundreds of billions of stars. Clouds of gas and dust weave between them, glowing with the birth of the new suns. At its heart lies a supermassive black hole, quietly anchoring the galaxy with its gravity. Around it all, an invisible halo of dark matter provides stability. The Milky Way is your home, your cosmic city, your place within the larger web. And beyond it lie billions of others. Andromeda, your nearest large neighbour, spirals just 2 million light-years away. One day, billions of years from now, the Milky Way and Andromeda will merge, creating a new, larger galaxy. Even galaxies evolve, even galaxies change. There is beauty in this impermanence. Nothing in the cosmos is fixed. Stars are born and die. Galaxies collide and merge. Structures stretch and transform. Yet out of this endless change comes continuity, complexity, and life. You rest in this rhythm, letting it soothe you like waves against a shore. The universe gathers and scatters, brightens and darkens, builds and dissolves, and always, always creates anew. The birth of galaxies marked a turning point. For the first time, the universe had structure on grand scales. Light filled the void. Chemistry spread. The stage was set for planets, for oceans, for minds that would one day look back in wonder. And you lying here are one of those minds. You are the universe reflecting on itself, stardust dreaming of galaxies. The galaxies above are not separate from you. They are your kin, your origin, your vast family. Yet, as galaxies formed, another puzzle grew clear. If so much matter, both visible and dark, gathers into webs, why does the universe continue to expand? Why do galaxies drift apart even as gravity binds them together? This question leads you gently onward, like a lantern flickering at the edge of sleep. Galaxies are the architecture of the cosmos, but what invisible force decides the fate of their expansion? You lie in the quiet of the night, and above you galaxies shimmer like lanterns on a boundless sea. Yet what you see is only part of the story. The light is a veil. Behind it lies something vaster, more mysterious, a fabric that holds the galaxies in place. This is dark matter, the invisible skeleton of the cosmos. Close your eyes and imagine walking through a great cathedral. Its walls are high, its arches strong, yet you see only the stained glass glowing with colour. The stone pillars, the beams that hold the ceiling, they are hidden in the dim light, almost forgotten. Dark matter is like those pillars, unseen yet essential, the quiet strength that allows beauty to rise and remain. For decades, astronomers puzzled over galaxies. They spun like wheels, their stars circling at tremendous speeds. Yet when scientists calculated the mass of the visible stars and gas, it was not enough. By all logic, galaxies should have flown apart, their stars scattering into the void. But they did not. Something unseen was holding them together. This discovery was not sudden. In the 1930s, a Swiss astronomer named Fritz Zwicky studied the Coma cluster, a vast group of galaxies. He noticed that galaxies within the cluster moved too fast to be bound only by the matter he could see. He suggested the presence of dunkel materia, dark matter. At the time, his idea seemed strange, but decades later it became unavoidable. By the 1970s, Vera Rubin and her colleagues measured how stars rotate around galaxies. They expected stars farther out to move more slowly, as planets in our solar system do. Instead, the stars at the edges spun just as quickly as those near the centre. It was as if some invisible mass surrounded galaxies, creating an unseen halo of gravity. Dark matter was no longer a guess. It was the only explanation. Now, pause and picture this. Every galaxy, including your Milky Way, is embraced by a halo of dark matter. You cannot see it, cannot touch it, yet its pull is undeniable. Without it, galaxies would not hold together. Without it, stars would not cluster, planets would not form, and you would not exist to wonder about it. What is dark matter made of? That remains a mystery. It is not atoms, not the familiar particles that make you, the Earth, or the stars. It does not emit light or absorb it, making it invisible to telescopes. Scientists propose exotic particles, WIMPs, weak interacting massive particles, axions, or perhaps something stranger still. Experiments deep underground, shielded from cosmic rays, search for faint whispers of these particles. So far, the silence remains, and yet, even in silence, the evidence is overwhelming. Look at the cosmic web, the grand structure of the universe. Its threads are shaped by dark matter, guiding galaxies like beads strung on invisible strings. Computer simulations show this clearly. Without dark matter, the universe would not look as it does. With it, galaxies gather along filaments, forming the same web observed through telescopes. Imagine this cosmic web as lace spread across infinity, delicate yet strong. The bright points of galaxies are like beads sewn into the threads. Between them lie vast voids, emptiness shaped not by chance but by the invisible pull of dark matter. Dark matter makes up about 27% of the universe. By comparison, all the stars, planets, gas and dust, everything you can see, amounts to less than 5%. The rest is something else, something even more mysterious: dark energy. But dark matter alone reminds you how little of the cosmos is visible. Most of reality hides beyond sight. And yet this is not cause for fear. It is cause for wonder. The fact that you are held in place by something unseen, something silent, tells you that mystery itself is part of your story. You are shaped not only by light but by darkness, not only by the known but by the unknown. Breathe slowly and let this comfort you. You do not need to see all things to be part of them. The air you breathe is invisible, yet it sustains you. The gravity that anchors you to Earth is invisible, yet you trust it completely. Dark matter is another invisible companion, steady and dependable, even if its true nature remains veiled. Now, think of the Milky Way. Beneath its spiral arms, its gas clouds, and its stars lies a vast dark halo, perhaps 10 times more massive than all the visible matter combined. It extends far beyond what you can see, enveloping not just the galaxy, but its satellites, the Magellanic Clouds, small companion galaxies that orbit like fireflies near a lantern. Without dark matter, the Milky Way's arms would unravel. Without dark matter, the local group would disperse. Even the future merger of the Milky Way and Andromeda depends on dark matter's steady embrace. It is the stage on which the cosmic dance unfolds. Some scientists suggest that dark matter may one day be detected directly, its particles caught in detectors on Earth. Others wonder if it is not matter at all, but a sign that our understanding of gravity is incomplete. The mystery endures, whispering of truths still beyond reach. But you do not need to solve the mystery tonight. You need only to rest in its presence, to imagine the unseen fabric cradling the stars, to let the thoughts soothe you like a lullaby. Dark matter teaches a quiet lesson. Not all that is real must be visible. Not all that is essential must be known. Some truths can be trusted even in shadow. As you drift deeper into calm, imagine yourself suspended in the cosmic web. The threads hold you gently, like a hammock stretched across infinity. You sway between galaxies, secure in the knowledge that unseen forces cradle you as surely as the Earth cradles your body. The story of dark matter is not an ending, but an opening. If invisible matter shapes galaxies, what then shapes the universe itself? What force could stretch space, push galaxies apart, and decide the destiny of all things? That question awaits you like a lantern glowing softly ahead. You lie in stillness, and the stars seem steady above you. Yet if you could watch them over billions of years, you would see them drift apart, the vast ocean of space stretching wider and wider. This quiet separation is the work of something even more mysterious than dark matter. It is called dark energy, the whisper that drives the expansion of the universe. For a long time, astronomers believed that gravity should slow the universe's growth. Like a stone tossed into the air, they thought space would rise but eventually fall back, perhaps collapsing in a grand reversal known as the Big Crunch. But when scientists looked closer, when they measured the light of distant supernovae in the 1990s, they discovered something astonishing. The expansion was not slowing. It was speeding up. Pause for a moment. Let this sink in. The universe is not only expanding, it is accelerating. Galaxies are carried away from each other faster and faster, as if space itself is swelling beneath them. Something unseen is pushing the cosmos apart, filling the void with quiet insistence that something is dark energy. Unlike dark matter, which pulls, dark energy pushes. Dark matter gathers galaxies. Dark energy scatters them. Dark matter is the unseen glue. Dark energy is the unseen wind. Together they weave the story of cosmic balance, a tension between holding and letting go. What is dark energy made of? No one knows for certain. It may be the energy of the vacuum itself, the subtle hum of empty space. Quantum physics tells us that even the emptiest void is not truly empty. Particles flicker in and out of existence like sparks of possibility. Perhaps dark energy arises from this restless activity, a background pressure stretching the fabric of space. Or perhaps it is something stranger, a new field woven into reality, unknown to current science. Whatever its nature, its effect is undeniable. Dark energy makes up about 68% of the universe. More than 2/3 of everything is not matter, not light, but this mysterious energy of expansion. Imagine yourself afloat in a boundless sea. Dark matter is the net that holds the galaxies together, while dark energy is the current that pulls the sea itself outward, carrying everything with it. You are both held and carried, both anchored and set adrift. Think of galaxies as islands scattered across an ocean. They are fixed in place within their own shores, bound by gravity and dark matter, yet the water between them stretches endlessly. The islands do not move across the sea itself expands. So it is with galaxies. They do not sail through space. Space itself expands between them. This is why the farther away a galaxy lies, the faster it seems to recede. It is not rushing through space like a starship. Rather, the fabric of space grows and the galaxy is carried with it. Expansion is not movement but creation, new space unfolding everywhere at once. Now, breathe slowly. Imagine the air around you gently stretching, the room quietly growing without noise. This is how the universe behaves. No explosion, no sound, just the silent widening of infinity. The discovery of dark energy changed everything. It told us that the universe's destiny is not collapse, but expansion without end. If dark energy remains constant, galaxies will drift farther apart until their light no longer reaches one another. The night sky billions of years from now may appear empty, stripped of stars beyond the local group. The cosmos will become vast, cold and silent, each galactic island isolated in darkness. This vision may feel lonely, yet it is also tender. Expansion allows the universe to evolve, to create room for galaxies, stars, planets, and life. Without dark energy, the balance would shift. Without expansion, the cosmos might have collapsed long before you arrived. Dark energy teaches you that even emptiness has power. Even silence can shape destiny. What appears void may carry within it the deepest force of all. Some physicists suggest that dark energy is connected to the cosmological constant, an idea first proposed by Einstein. He introduced it into his equations to keep the universe static, then later called it his greatest mistake. Yet perhaps it was no mistake at all. Perhaps the constant he imagined was real, a steady, gentle pressure woven into space itself. Others wonder if dark energy may change with time, growing stronger or weaker, leading to different cosmic fates. If it grows stronger, expansion could accelerate so violently that galaxies, stars, even atoms might be torn apart, a scenario called the Big Rip. If it weakens, perhaps expansion will slow and gravity might regain control. But tonight, you need not solve this mystery. You need only to feel its rhythm, the gentle breath of the universe widening around you. Expansion is the cosmos exhaling, a steady sigh that continues through eternity. And in that sigh you find calm. You rest within a universe that is not still but alive, always stretching, always unfolding. You belong to that unfolding, carried gently in its tide. Look inward now. Just as galaxies drift apart, your thoughts can drift into spaciousness. Just as dark energy expands the cosmos, you can let your mind expand, releasing its grip, opening to quiet. The mystery itself becomes a lullaby. Dark energy may remain unnamed, but its presence is certain. It is the whisper in the silence, the widening in the stillness, the unseen current that guides all things toward openness. As you sink deeper into rest, imagine this whisper, not as something foreign, but as part of you. For you too are mostly emptiness. Atoms are not solid but filled with space, their particles tiny compared to the void within. The same emptiness that expands galaxies also fills your being. You are kin to the cosmos, a mirror of its mystery. You drift now in that kinship, in the quiet recognition that the universe expands both outward and inward, both in space and in spirit. But a question lingers, like a candle flickering at the edge of thought. If dark matter shapes the galaxies and dark energy shapes the universe, then what shaped the very beginning? What spark set all of this into motion? Close your eyes and imagine a universe without light. No stars, no galaxies, no glow at all, only a thick fog of particles, restless and warm, pressing against one another. This was the cosmos in its earliest moments, before clarity, before radiance. In those first hundreds of thousands of years after the Big Bang, the universe was dense and hot. Protons and electrons moved too wildly to settle into atoms. Photons, the particles of light, scattered constantly, bouncing off free electrons, unable to travel far. The cosmos was opaque, like a mist so thick you could not see your own hand. And then, slowly, the fog began to thin. The universe expanded, cooled, and at last particles calmed enough to unite. Protons captured electrons, forming the first simple atoms of hydrogen and helium. This era is called recombination, though it was the first time atoms truly formed. With electrons bound inside atoms, photons were freed. No longer trapped in endless collisions, light could travel vast distances, unhindered. In that moment, the universe became transparent. This was the release of the first light. Pause here, let your breath slow, and imagine that unveiling. The fog lifts, and light pours through space for the first time, like dawn breaking after an eternal night. The cosmos itself glowed with a soft radiance, filling every direction. That ancient light still exists. It has stretched with the universe for billions of years, cooled into faint microwaves that fill all of space. We call it the cosmic microwave background, a gentle echo of the first light, still humming softly, surrounding you even now. Think of it as a baby picture of the universe, a record of its earliest visible form. Tiny ripples in that light, small differences in brightness, were the seeds of galaxies, the first hints of structure. From those ripples, gravity would weave stars and clusters, the grand architecture of the cosmos. The first light was not the brilliance of stars. It was gentler, more universal, a glow everywhere at once. It did not shine from a single source, but from all of space itself, like the universe exhaling in a sigh of radiance. Breathe with it now. Inhale, and imagine the fog of early particles. Exhale and see it clear, revealing a cosmos filled with light. You are synchronized with that ancient rhythm, your breath an echo of cosmic dawn. The release of the first light marked the end of the universe's childhood. It was now transparent, open, and ready for new creations. But darkness lingered. Though light was free to travel, no stars yet burned. The glow faded into dimness, and the cosmos entered what astronomers call the cosmic dark ages. In that long silence, atoms drifted in vast clouds, cooling and waiting. Gravity slowly gathered them into knots, and within those knots, the first stars would ignite. But for millions of years, the universe was filled mostly with hydrogen, helium, and the whisper of that ancient glow. Even in the dark ages, however, the first light remained, faint, stretched, yet present. Scientists today build delicate instruments to detect it. Satellites like COBE, MAP, and Planck have mapped it in detail, showing us the universe as it appeared nearly 14 billion years ago. It is humbling to think that when you tune a radio between stations and hear static, part of that hiss is the faint echo of the first light. Now, imagine yourself drifting back into that moment. Around you is no star, no planet, only a soft, all-encompassing glow. The universe is young, vast, and nearly featureless. Yet within that apparent simplicity lies everything to come. That glow is like the memory of the cosmos, a quiet reminder of its origin. It tells you that light and darkness are partners, that beginnings are often subtle, that even the faintest radiance can carry the promise of galaxies. You too carry such light. Within your body are atoms forged long after this first glow, but their roots reach back to that time. The hydrogen in your cells was born in those early atoms, shaped in the quiet after the Big Bang. When you breathe, when you move, you carry the remnants of that ancient dawn. Pause, and let that thought comfort you. You're not separate from the first light. You're its continuation. The universe's story is one of patience. From the first light came centuries of waiting, of cooling, of preparation. The stars would come, but not yet. The galaxies would rise, but only after gravity worked slowly across the silence. There is a lesson here, that not all brightness bursts forth at once. Some lights require time, some beauty grows in quiet, unseen, waiting for the right moment to shine. The first light faded into the dark ages, but it never disappeared. It stretched with the universe, red-shifting, cooling, softening, until it became the background glow we know today. Its persistence reminds you that nothing is lost, only transformed. As you rest, let this transformation ease your thoughts. The glow that began nearly 14 billion years ago still lingers, and so too can the quiet light within you linger, no matter how dark the night may seem. The first light was not a blaze, but a whisper. Not a star, but a glow. Not a moment of triumph, but of release. And yet it was enough. Enough to begin, enough to guide, enough to carry the story forward. You lie within that story now, drifting in its current. Above you galaxies shine, but beneath their brilliance lies the memory of the first glow, a gentle reminder that all light begins softly. And just as the universe once transitioned from fog to clarity, from shadow to radiance, so too do you drift now toward deeper understanding. For soon the darkness will break again. Stars will ignite, galaxies will bloom, and the universe will awaken to a new era of brilliance. But for now you rest in the quiet afterglow, listening to the faint hum of the cosmos, knowing that even the smallest whisper of light can change everything. Imagine a universe that has just exhaled its first breath of light. The fog has cleared, photons stream freely, yet no stars twinkle, no galaxies shine. What stretches before you is vast, dim, and almost empty of structure. This is the beginning of the cosmic dark ages, a time of waiting, a pause between the glow of the first light and the ignition of the first stars. Close your eyes and feel the stillness of this era. Hundreds of millions of years pass, yet little seems to change. The universe is filled with hydrogen and helium, the simplest elements drifting like mist across a boundless sea. Light from recombination still glows faintly in the background, but it has stretched, dimmed, and cooled. The cosmos is quiet, wrapped in its long night. These dark ages are not emptiness, but preparation. Gravity works slowly, patiently, gathering clouds of gas together. At first, the clumps are small, fragile, easily disrupted. But over time, the knots of matter tighten. Invisible halos of dark matter provide scaffolding, pulling gas into deeper wells of gravity. Within these hidden cradles, the seeds of the first stars begin to form. You might think of this time as the silence before music begins, the hush of a theatre just before the curtain rises. The stage is set, the instruments are waiting, but the melody has not yet begun. The universe is poised, gathering energy for the first performance of starlight. Astronomers study these dark ages through faint signals, the most famous being the 21-centimeter line of hydrogen. When atoms of hydrogen flip their spins, they release a soft radio signal. As the universe expanded, this signal stretched into longer wavelengths. Detecting it today would allow us to map the unseen structure of those ancient times. Projects like the Square Kilometre Array aim to tune into this whisper, to hear the faint hum of hydrogen across the early universe. Pause and imagine listening to that hum, a sound too soft for ears, yet present in the silence of space, a record of clouds gathering in the dark. It is the quiet music of patience, the slow rhythm of becoming. During the Dark Ages, the universe was cooler than before, but still warm compared to the present. The background radiation glowed in infrared, invisible to human eyes but filling every corner. The gas itself was neutral, unionized, waiting to be awakened by the heat of the first stars. It is easy to picture darkness as lifeless, but here, darkness is gestation. The universe is pregnant with potential, carrying within it the seeds of every star, planet, and living being to come. Let this thought comfort you. Darkness is not always an ending. Sometimes it is the soil in which light takes root. Sometimes it is the pause that allows the future to unfold. The cosmic dark ages lasted for hundreds of millions of years. To you, that span feels unimaginable. Yet in cosmic terms, it was brief. Soon gravity would compress hydrogen clouds so tightly that fusion would ignite. The first stars would blaze, flooding the universe with ultraviolet light. That light would break apart the hydrogen, ionizing it, and ending the cosmic dark ages. This transition is called reionization, a rebirth of radiance, the lifting of the long night. But in the meantime, the universe rested. Imagine drifting through that time surrounded by vast dark clouds of hydrogen. There is no horizon, no familiar stars to guide you. Only faint background glow, soft and stretched, and the endless silence of becoming. You are suspended in stillness, as though the universe itself is dreaming. Darkness here is not frightening. It is soft, like a blanket drawn across the sky. It holds you, lulls you, invites you to rest. It tells you that creation can take its time, that nothing need rush, that even in the absence of light, progress is unfolding quietly. Scientists sometimes call this period the lost era, because it is so difficult to observe directly. Yet though hidden, it was essential. Without the Dark Ages, there would then be no stars, no galaxies, no worlds. Silence is part of every song, shadow is part of every dawn. As you lie here, think of your own pauses, your own quiet stretches between brightness. Life, like the cosmos, has its dark ages, times of stillness, of waiting, of apparent emptiness. Yet within them unseen forces gather, preparing for what comes next. The cosmic dark ages were not a void, but a womb. The gas clouds were the embryos of stars, the filaments of dark matter, the veins through which structure would grow. Out of this silence, brilliance was destined to emerge. And so you rest in that silence, letting it surround you, letting it teach you patience. Not all light comes immediately. Not all creation is loud. Some beginnings are quiet, hidden, and slow. Breathe deeply now. With each inhale, imagine the hydrogen clouds drifting together. With each exhale, imagine the stillness, the pause, the long night. You are synchronized with the rhythm of the universe in its most tranquil age. At last, your mind turns gently to what comes next. In the deep pockets of gas, fusion is about to awaken. The first stars will ignite, brilliant and short-lived, flooding the darkness with ultraviolet light. They will transform the cosmos, bringing the dark ages to an end. But for now, you linger in the hush, floating in the pause before brilliance. The universe teaches you that darkness can be fertile, that silence can be holy, that waiting itself is part of the grand design. Rest here, held by the dark ages, for soon the stars will come, and with them the universe will awaken to its first true dawn. The dark ages stretch on, a hushed lullaby of hydrogen and shadow. You drift through this quiet, weightless and still, as though the cosmos itself is asleep. But within the silence, tension builds. Gravity pulls, squeezes, and gathers. Invisible dark matter halos tug at clouds of gas, urging them inward. Slowly, almost reluctantly, hydrogen begins to collapse. At first, the collapse is gentle, a soft gathering. But as the cloud grows denser, it heats. Particles collide, pressure builds, and at last, fusion awakens in the heart of the cloud. A spark, then a blaze, a star is born. The first stars of the universe ignite. They are not like the calm yellow sun you know today. These are titans, massive and short-lived, blazing with a brightness far beyond their size. Astronomers call them population 3 stars, the very first generation. Made only of hydrogen and helium, they are pure, unpolluted by heavier elements. Their light is harsh, searing ultraviolet, pouring into the darkness. Imagine the sudden change. For hundreds of millions of years, the universe was quiet. Now, one by one, stars flicker to life, scattering light across the cosmos like sparks leaping from a campfire. Each new star pierces the dark ages, carving out a glowing bubble in the hydrogen fog. Soon the bubbles overlap, and the universe is no longer silent but radiant. The stars are fierce and they live quickly. Many are hundreds of times more massive than the sun. They burn their fuel in a few million years, compared to the billions our star will last. In cosmic time, they are fireflies, brief flashes of brilliance, but powerful enough to change everything. In their cores, fusion weaves hydrogen into helium, helium into heavier elements, and when these massive stars die, they explode as supernovae, scattering carbon, oxygen, and iron into the universe. The first ingredients of life are sown into the cosmic soil. Pause here. Breathe in. Imagine yourself standing in that first starlight. The sky is no longer a uniform dark, but a blossoming field of sparks. Each star is a beacon, a promise, a seed of future worlds. Their ultraviolet light sweeps outward, ionizing hydrogen, stripping electrons from protons. This reionization changes the universe itself, ending the long night and opening the era of transparency. Suddenly, galaxies can take shape, structures can grow, and pathways of light can stretch unhindered across space. The stars are teachers. They show you that brilliance often comes from pressure, that fire awakens when collapse becomes too great to bear. In your own life, too, moments of wait can give rise to sudden light. bursts of clarity, new beginnings. Yet the first stars also remind you of impermanence. Their lives are short, their brilliance fleeting, but in their endings they give more than they took. Their supernovae spread the elements that will form planets, oceans, and you. Out of their ashes, the possibility of life emerges. Astronomers cannot see these stars directly. They are too distant, too brief. Yet their fingerprints remain in the cosmic background, in the distribution of elements, in the rionized fog. The James Webb Space Telescope peers toward this era, searching for their glow, seeking the first sparks in the darkness. Close your eyes and imagine it. Great clouds collapsing, stars igniting like torches, explosions scattering stardust. The universe grows louder, brighter, more alive. The long night gives way to dawn. In this moment you may realize something profound. The atoms within you were born in stars like these. Your carbon, your oxygen, your iron, all forged in stellar furnaces. When you breathe, when you move, you are carrying the memory of these first fires. You are, quite literally, made of stardust. Feel the warmth of that truth. You are not separate from the cosmos. You are its continuation. The first stars ignite not only for themselves, but for every future being, every thought, every dream. Their fire lives on in you. Now, drift slowly through this newborn cosmos. Around you, clusters of stars form, bound by gravity into the earliest galaxies. Filaments of matter thread across the void, weaving a great cosmic web. The universe is no longer silent but filled with activity. Stars burning, collapsing, exploding. This is the era of illumination, the Great Awakening. And yet, it is only the beginning. From here, galaxies will grow, clusters will gather, and the cosmos will blossom into its modern form. But all of it begins with these first stars, brief, powerful, and transformative. Let the rhythm of their story soothe you. Pressure into fire, fire into elements, elements into life. A cycle of creation, destruction, and renewal, a reminder that even the brightest lights must fall. And yet in fading they give birth to more. As you breathe slowly, feel the light of the first stars enter you, not as blinding brilliance, but as a gentle warmth, a quiet reassurance. Their fire is your fire, their story your story, and as the chapter closes, you sense what lies ahead. Out of the explosions of these first stars, galaxies will rise. The scattered elements will gather again, forming new generations of stars, planets, and paths toward life. The universe has begun to weave its grand tapestry, and you are drifting toward the next thread. You drift from the brightness of the first stars into a deeper stillness, watching as their light softens across the vast canvas of space. The universe, once scattered with solitary sparks, now begins to organize itself. The first stars do not remain alone. Gravity, patient and persistent, draws them together. Like dancers moving toward one another, they gather, spiraling inward, forming clusters that grow into something larger. Galaxies are being born. Imagine them as cosmic cities, each star like a glowing lantern, millions upon millions collected into neighborhoods of light. Where once there was only gas and darkness, now there are luminous islands drifting through an endless ocean. These galaxies are young, irregular, and wild. Their shapes are not yet the graceful spirals you see in modern skies, but chaotic, tangled, still learning their form. At their hearts, gravity deepens. Clouds of dark matter, invisible but massive, cradle these galaxies, holding them together. Without dark matter, the stars would scatter like fireflies, unable to cling to one another. But with this hidden scaffold, they remain bound, swirling into collective shapes. You cannot see the dark matter, but you can feel its presence in the way galaxies hold their form, the way they endure. As time flows, patterns sharpen. Some galaxies stretch into spirals, their arms curling like seashells or whirlpools, delicate yet immense. Others condense into elliptical clusters, glowing spheres of stars, their motion less ordered, but equally breathtaking. Still others remain irregular, rough drafts of galactic beauty. Pause here. Imagine floating at the edge of a young galaxy, watching stars swirl past. The scale is unimaginable. Hundreds of billions of suns in one vast city of light. And yet, from a distance, it looks like a single shimmering shape, a flower blooming in darkness. These galaxies do not live in isolation. Like islands in an archipelago, they gather into clusters and superclusters, connected by filaments of matter. The great cosmic web takes form, strands of galaxies stretching across the universe, knots where they meet, voids of emptiness between them. You are drifting through the largest structure ever conceived, and yet it feels gentle, like lace unraveling in water. The birth of galaxies is also the birth of history. Within their spinning arms and crowded centres, stars live and die. Supernovae enrich the galaxies with heavier elements. Gas clouds collapse into new generations of stars. In time, planets form around some of those stars. Galaxies become nurseries not only of light but of potential life. Look inward for a moment. The Milky Way, the galaxy that cradles you now, began its story in this era. At first it was just a small cluster of stars and gas, fragile and forming. But over billions of years it grew by merging with other young galaxies, colliding and absorbing them. These galactic dances continue even today, vast collisions that take millions of years, slow as drifting clouds. From your resting place in thought, you watch two galaxies approach each other. Their shapes stretch and twist, tidal forces pulling out streams of stars, gas colliding, sparking waves of new starbirth. It looks like violence, but it is also creation. Galaxies grow through encounter. Out of chaos, beauty emerges. The universe begins to look familiar now. The large-scale structures you see today trace their roots to this time. The night sky you know, filled with galaxies too faint for your eyes but visible through telescopes, is a tapestry woven from these first gatherings. Galaxies teach you about belonging. Stars alone can shine, but together they create patterns of wonder. Just as individuals form communities, galaxies are collections that become more than the sum of their parts. They hold memory, growth, and the seeds of future stories. Drift deeper into the spiral arms of a galaxy. Clouds of gas glow with newborn stars, nebulae painted pink and blue by the light of creation. Older stars circle quietly, steady and golden. In the dense centre, a dark secret hides. A supermassive black hole. Almost every galaxy has one, millions or billions of times the mass of a star, anchoring its core. These black holes are not voids of destruction alone. They regulate galaxies, shaping the flow of gas, sometimes triggering star formation, sometimes quelling it. Even in darkness there is guidance. Even in silence, influence. You may wonder, how do these immense structures endure? The answer lies in time. Galaxies are patient. They evolve over billions of years, far longer than the span of human history. In their slow dance, they remind you that not all change is swift. Some beauty unfolds only through deep cosmic patience. The first galaxies you witness are smaller, dimmer than the giants you know today, but with each passing billion years, they grow, collide, and transform. Their light travels endlessly through space, reaching Earth billions of years later. When you look at the faint glow of a distant galaxy, you are seeing its youth, its early chapters. You are gazing backward in time. The galaxies call to you softly. Remember that every light has a story. Every structure has a history. You too carry the memory of beginnings within you. The atoms in your body were once carried in these galactic arms, scattered by ancient stars drawn together into new worlds. Let this truth soothe you. You are not separate from the galaxies. You are part of them, written in their spirals, shaped by their collisions. Their story is your story, and their endurance mirrors your own ability to grow, to gather, to transform. As you drift gently onward, you notice something beyond the galaxies themselves. Despite their light and their gatherings, the universe continues to expand. The fabric of space stretches, carrying galaxies farther apart from one another. Though they cluster in webs, the web itself grows wider, thinner, more spacious. Expansion does not end with galaxies. It continues, patient and unstoppable. And so, as you breathe with the rhythm of the cosmos, you prepare to listen more closely to that expansion. The galaxies have shown you their form, their beauty, their role as homes for stars and seeds of life. But why do they drift away from one another? What invisible presence is guiding this expansion, stretching the universe ever wider? You are ready to follow that question into the dark. You drift once more into the galaxies, watching their spirals unwind across the night. Stars orbit gracefully, moving in patterns that should not hold. You expect the outer stars to drift away, pulled too weakly by the visible matter within. Yet they remain, circling steadily, as though tethered by an unseen force. Here lies the first whisper of dark matter. It is not light, nor gas, nor star. It does not shine, does not absorb, does not reveal itself to telescopes. But its presence is undeniable, written into the very motion of galaxies. Without it, the spirals would unravel, the galaxies would scatter. Instead, they endure, bound together by an invisible hand. Astronomers first noticed this mystery when studying the rotation curves of galaxies. The outer stars moved too quickly to be held by visible matter alone. Something more massive was at work, though unseen. This something became known as dark matter. Not dark as in shadowed, but dark as in hidden. Close your eyes. Imagine walking through a forest at night. You cannot see the roots beneath the soil, but you feel their strength in the trees they support. Dark matter is like those hidden roots, unseen yet essential. Galaxies are the trees, their spirals held steady by foundations you cannot touch. Drift deeper into thought. Dark matter makes up about 85% of all matter in the universe. The atoms you know, the stars you see, the planets you touch, are only a fraction of what truly exists. Most of matter is invisible, silent, waiting, and yet without it the universe would have no shape. Think of the early cosmos, filled with clouds of hydrogen after the Big Bang. Dark matter, clumping first, formed gravitational wells, hollows where gas could collect, collapse, and ignite into stars. Without this scaffolding, the first galaxies might never have formed. Dark matter is not only a stabilizer, it is a creator, a framework. Scientists do not yet know what dark matter is. It may be made of undiscovered particles, faint and elusive, slipping through detectors without trace. It may be something stranger still, woven into the very laws of gravity, and yet its influence is everywhere. Every galaxy you see is wrapped in a dark matter halo, like a cocoon of invisibility. Pause and let the idea settle. The universe is mostly made of things you cannot see. The visible is only a thin surface, a shimmer above deeper layers. You live each day among atoms and light, but the greater weight is elsewhere, hidden, silent. This truth can comfort you. Not all that matters must be seen. Support can be invisible and still enduring. Like unseen kindness, like unspoken care, dark matter reminds you that presence is not always visible, yet it is no less real. Now imagine yourself moving through a galaxy's halo. There is no glow, no dust, only emptiness. Yet you feel the pull, the gravity shaping your path. The stars orbit around you, each one obeying the silent pull. You are part of the pattern, carried by the weight of what you cannot see. Astronomers map dark matter indirectly. They measure the bending of light, gravitational lensing with Borst, when background galaxies appear distorted by the mass of unseen halos. It is as if space itself is a sheet of glass warped by invisible hands. Through these distortions, the outlines of dark matter come into focus. The map that emerges is like a shadow skeleton threading the cosmos, forming the great web of structure. Step back in your mind. The cosmic web is not only stars and galaxies, it is filaments of dark matter stretching vast distances, connecting clusters, shaping the architecture of all that exists. What you see as galaxies are beads of light on invisible threads. This thought may feel humbling. The universe is not built on what is seen but on what is hidden. Your own life, too, may be supported by things unnoticed. Memories, values, love, unspoken, gravity of the heart. Dark matter does not shine, but it defines the shape of light. You may wonder, if it is everywhere, why can't we touch it? Dark matter does not interact with light or ordinary matter the way atoms do. It passes through without collision, a ghostly presence. Detectors buried deep underground wait for a rare signal, but so far silence. This silence is its signature, its mystery. Still science continues. Perhaps one day the veil will lift. Perhaps one day we will discover the particles that make up this hidden mass. Until then, we live in its presence, guided by its gravity. You breathe slowly. Think of how stars orbit not only around the centers of galaxies but around the invisible halos. Think of how clusters of galaxies themselves are bound by larger halos of dark matter. Everywhere it is the silent pull, the hidden thread. Dark matter shows you a paradox. The most important structures may be the ones unseen. The unseen gives shape to the visible. The hidden gives strength to the apparent. The galaxies you admire at night are only the surface glow of something far greater beneath. Let this truth sink deeper into your thoughts. The beauty of the universe rests on invisible foundations, and so do you. Now, gently, the chapter shifts. You recall that dark matter explains why galaxies hold together, but it does not explain why the universe expands faster and faster. There is another mystery deeper still. If dark matter binds, what is it that drives galaxies apart? The silent pull steadies you, but beyond it lies another presence, not of gathering but of scattering, a force not of attraction but of expansion. And so, as you drift between the luminous spirals and their hidden halos, you prepare to turn your gaze to this other enigma, waiting in the fabric of space itself. You rest in the spaces between galaxies, where darkness stretches wide and unbroken. At first glance it feels empty, a vast nothing, a silent void. Yet here, in this apparent emptiness, the deepest mystery of the universe resides. For centuries, people thought of space as a vacuum, an absence. To be empty meant to be nothing. But the universe whispers otherwise. Even in the quietest corners, even where no star glows and no particle drifts, there is energy. Invisible, subtle, and yet undeniable. This is the vacuum energy, the weight of nothing. Close your eyes and imagine a blank canvas. At first it seems bare, but as you look longer, patterns emerge, tiny brushstrokes, faint textures, details hidden beneath simplicity. Space is like that canvas. Beneath its seeming emptiness, it is alive with invisible fluctuations. Quantum physics tells you that the vacuum is never truly still. Tiny pairs of particles flicker in and out of existence, appearing and vanishing in the blink of a thought. These quantum fluctuations ripple endlessly, giving space itself a restless background hum. This hum may seem small, yet it carries enormous weight. Spread across the vastness of the universe, this hidden energy shapes the destiny of everything. Breathe slowly and let that image settle. Nothing is not nothing. Even absence has substance. When scientists studied the universe's expansion, they expected gravity to slow it down over time, but instead the expansion was accelerating. Something unseen was driving galaxies apart. Could it be that the vacuum itself, the very fabric of space, carried energy that pushed outward? Einstein once introduced a cosmological constant to his equations, a subtle force within space itself, balancing gravity. Later he called it a mistake, and yet modern discoveries suggest he may have glimpsed the truth after all. The vacuum is not weightless. The vacuum has power. Imagine space as a fabric stretched across a loom. If the fabric were truly empty, it would lie still, but instead it swells gently as if filled with breath. Each new patch of space created by expansion carries its own energy, amplifying the effect. The more the universe grows, the more energy fills it, and the faster the expansion becomes. This is dark energy in its simplest form, the energy of emptiness. You drift in thought, letting the paradox soothe you. How can nothing be something? How can emptiness weigh more than matter? The cosmos does not answer directly, but invites you to sit with the mystery. Sometimes questions are more restful than solutions. In your own life too, emptiness is rarely truly empty. Silence holds emotion. Pauses in conversation carry meaning. A blank page holds the possibility of words. The weight of nothing reminds you that absence can be as powerful as presence. Now imagine yourself surrounded by galaxies, each one carried outward on the current of expansion. They do not race through space like ships across an ocean. Instead, the ocean itself expands, stretching the distance between them. The more space grows, the more vacuum energy there is to drive the growth further. It is a feedback loop written into the fabric of reality. And yet, there is strangeness here. When physicists calculate the vacuum energy from quantum theory, The predicted number is vastly larger than what we observe. The math suggests a universe that should tear itself apart instantly, a cosmos too violent to exist. But in reality, the measured value is small enough to allow galaxies, stars, and life to form. This puzzle is known as the cosmological constant problem. No one knows why the vacuum's energy is tuned so delicately. Too much, and the universe would expand too fast for stars to form. Too little, and gravity would have pulled everything back into collapse. Somehow the balance lies in between, gentle enough for beauty, strong enough for expansion. Let this balance comfort you. Out of infinite possibility, the universe found of soul to allow light, life, and wonder. Even in uncertainty there is harmony. You breathe slowly, held by the thought that nothingness itself carries a secret fullness. The silence of the vacuum hums softly, unseen but ever present. Scientists name it, measure it, and search for its origin, but it remains elusive. Some imagine it as a property of space itself, woven into the cosmos. Others wonder if it points to new physics, new layers of reality we have yet to uncover. For now, it is mystery, and mystery can be restful. Drift with it. The weight of nothing holds you, carries you, reassures you. In the emptiness of space, in the pauses of your own life, there is presence. There is meaning. You are not apart from this. The vacuum surrounds you, even now, in the room where you rest, in the spaces between atoms of your body. The unseen fullness of space is part of you, woven into your being. Let that thought be your lullaby. Emptiness is never truly empty. Even in silence there is energy. Even in nothing there is something. And as you linger on this truth, the question grows softer but deeper. If nothing can carry such weight, what else lies hidden in the fabric of the universe? What other secrets rest in the quiet, waiting to be felt? Close your eyes and imagine a grand cosmic scale. On one side lies gravity, the eternal pull gathering stars, planets, and galaxies into harmony. On the other side lies dark energy, the quiet push, stretching space itself, driving galaxies apart. The fate of everything rests upon their balance. From the first moments after the Big Bang, gravity was the master sculptor. It pulled tiny clumps of matter together, forming clouds, then spins, then galaxies. Without it, the universe would be a thin mist, forever spread out, never kindling light. Gravity is the architect of structure, the builder of homes for life, and yet, gravity is patient. It works slowly, across billions of years, always pulling a word, always binding. Its voice is soft but persistent, whispering the universe into form. But then, after eons of steady expansion, something strange began to happen. Instead of slowing, the expansion of space began to speed up. Another presence revealed itself: dark energy. This energy was not like matter, not like radiation, not like anything visible. It did not gather or clump. It acted everywhere equally, woven into space itself. Where gravity pulled together, dark energy pushed apart. Pause for a moment and feel the symmetry. Two forces, opposite yet intertwined. Without gravity, no stars would burn. Without dark energy, expansion would halt. Together they shape the rhythm of the cosmos. Imagine a cosmic dance floor. Gravity steps inward, pulling galaxies close. Dark energy steps outward, creating distance. The dance does not end, it only changes tempo. Sometimes gravity leads, sometimes dark energy. The universe is the music they move to. In the early universe, gravity held the stronger voice. Matter was synth, stars were young galaxies close together. Expansion slowed under the weight of attraction. Had dark energy not been present, perhaps the cosmos would have reached a peak and fallen back inward, collapsing into a final fire. But dark energy waited patiently. As the universe grew, as matter spread thin, gravity's hold weakened. In time, dark energy rose in influence, accelerating expansion. The balance shifted, and the dance changed. Now, in the present era, dark energy dominates. Galaxies drift apart more quickly with each passing billion years. Distances stretch, and the night sky grows ever more silent. This balance is not only physical, it's poetic. It reminds you of the balances in your own life. Times when one force pulls you inward, anchoring you, keeping you close. times when another force pushes you outward, inviting growth, change, and freedom. Neither is wrong. Both are needed. Without grounding, there is no stability. Without expansion, there is no discovery. The great cosmic balance teaches you that tension can be harmony. Opposites can sustain one another. Now picture the universe's future paths. If gravity had been stronger, the cosmos might have collapsed back into a fiery end, the Big Crunch. If dark energy continues as it does now, expansion may accelerate forever, galaxies drifting so far apart that each becomes an island alone in darkness. Stars would fade one by one until only quiet embers remain. This is called the heat death, the long months. But if dark energy grows stronger still, its push may one day rip galaxies, stars, even atoms apart. The Big Rip, a dramatic unravelling of everything. The truth is uncertain. The balance is delicate. The forces are vast. And yet here you are, small but alive, able to reflect on the dance of giants. That reflection itself is part of the beauty. Sit quietly and feel the lesson. Balance does not mean stillness. Balance can be dynamic, shifting, alive. The universe is not frozen in symmetry, but moving, breathing, swaying between forces. Think of a seesaw. At times, gravity's side is heavy, pulling down. At other times, dark energy rises, lifting higher. The motion itself is the story, and you are living within it. The galaxies above your head, the atoms within your skin all obey the same balance. The cosmos is not outside you. You are part of its dance. Gravity pulls your feet to the earth. Expansion stretches the very space your atoms rest in. You carry the balance within. This thought can be grounding. Even in times of tension, you are reminded that opposites can coexist. Pull and push, rest and motion, silence and sound. They are not enemies, but partners in a larger rhythm. The great cosmic balance also reveals humility. For all the equations, telescopes, and experiments, the exact nature of dark energy remains unknown. We measure its effects, but cannot yet name its essence. It is a reminder that mystery endures, that knowledge grows slowly, like galaxies forming under gravity's hand, and that is its own kind of balance, between knowing and not knowing. You can rest in that space. You do not need to solve every question tonight. You can let the mystery be a lullaby, a gentle reminder that not all things must be fully understood to be deeply felt. Now return to the image of the cosmic scale. On one side, matter and gravity. On the other, dark energy. The scale tips and shifts but never breaks. It is the balance of existence, the quiet equation behind every star you see. Let it soothe you. You too are part of this equation. Your breath is expansion and contraction. Your heartbeat is push and pull. Your life is gravity and energy, holding close and letting go. The cosmos teaches not only with stars, but with silence. In the hush of this chapter, you are invited to rest within the balance, to breathe in, pulled inward, to breathe out, expanded outward, to know that balance is not the end of motion, but the harmony of forces moving together. The great cosmic balance is not a final answer, but a continuing story. Gravity will always pull, dark energy will always push, and the universe will continue to dance between them. You are here for a brief step of that dance. Let it hold you gently as you drift towards sleep. Close your eyes and imagine standing on a quiet shore. The ocean stretches endlessly, its surface gleaming beneath a dim light. No matter how far you gaze, there is always a line, a horizon, where the water meets the sky. You know the ocean continues beyond that line, yet you cannot see it. The universe is like this too. Above you, the sky is not only dotted with stars, it is the record of light travelling across unimaginable distances. Every star, every galaxy, is a messenger from the past, whispering to you across space and time. But even messengers have limits. Beyond a certain distance, light cannot reach you, no matter how patiently you wait. That boundary is the cosmic horizon. This horizon is not made of stone nor of glass. It is not a physical barrier you could touch. Instead, it is woven from time itself. Light takes time to travel, and the universe has only existed for 13.8 billion years. That means you can only see light that has had enough time to arrive. Everything beyond remains hidden. Pause here and feel the weight of that thought. You live in a universe that is vast beyond imagination, yet you can see only a fraction of it. The rest is real, but invisible, waiting forever beyond your sight. Now picture a great bubble surrounding you. This bubble is not small, its radius is about 46 billion light years. Within it lies all the galaxies whose light has reached you since the dawn of time. Beyond it, galaxies continue, but their light has not yet arrived. The bubble is not fixed, it grows as time flows, as more light journeys across space. This bubble is called the observable universe. It is your personal horizon of forever, shaped by the limits of light. And yet, the horizon is not gentle. Expansion stretches space itself, carrying galaxies away faster and faster. Some galaxies retreat so quickly that their light will never reach you, no matter how long you wait. They are pulled beyond your horizon, lost to your sight forever. Like ships disappearing beyond the ocean's edge, they are real, but gone from your view. Think of this gently. The cosmos is not shrinking, but expanding. Your horizon is not a cage, but a window. It reminds you that vision always has limits, and that mystery is part of beauty. In your daily life too, horizons exist. You cannot see every future. You cannot know every detail of tomorrow. And yet that does not make tomorrow empty. It is full, waiting just as the hidden universe is full beyond your sight. The horizon of forever teaches humility. It reminds you that knowledge has edges, that even the brightest minds can see only so far. Beyond those edges lies wonder, not emptiness. Now let your mind drift farther. Imagine light itself as a traveller. A single photon leaves a galaxy billions of years ago. It begins its journey, racing through space, never slowing. Along the way, space itself stretches, pulling the photon's wavelength longer, dimmer, until it reaches you as a faint red glow. By the time it arrives, the galaxy it left may have changed completely. New stars born, old stars gone, shapes transformed. You're not seeing it as it is, but as it was. Every glance at the night sky is a glance into the past. The farther you look, the older the light. Galaxies become fossils of time, preserved in photons. The horizon of forever is not just the limit of space, it is the limit of time. Beyond it you cannot see because the past has not had enough time to deliver its message. Pause again and let this rhythm settle in you. The universe is not only vast, it is layered in time. You live within a sphere of memory, a glowing shell of ancient light. And yet even this is temporary. Expansion carries galaxies away. Slowly, they drift beyond the cosmic horizon. In billions of years, future observers may look up and see only their own galaxy, the rest hidden forever. The night sky will grow empty. The horizon will tighten like a closing curtain. This is the quiet tragedy of expansion. The universe becomes lonelier over time. The horizon does not only reveal, it also conceals. But in this moment, you're alive at a fortunate time. You can still see thousands of galaxies, still glimpse the vast network of cosmic structure. You live in an era when the universe is generous with its secrets. You stand at the shoreline before the tide recedes. This awareness is a gift. To know that horizons shift, that knowledge is fleeting, deepens your appreciation for what is visible now. The stars you see tonight are not permanent companions. Their light is a brief bridge across eternity. Now let the metaphor deepen further. The horizon of forever is not unlike your own inner horizon, the edge of what you can understand, imagine, or feel. Beyond it, there are experiences you cannot yet know, truths you cannot yet reach. That does not mean they are absent. They wait, unfolding as your life expands, as your vision deepens. The cosmos mirrors you. Just as the horizon of the universe grows as light travels farther, your own horizon grows as you gather time, memory, and reflection. Every year you see a little farther into what life holds. Every breath your horizon shifts, even if only by a fraction. This thought is gentle, not urgent. It means you are always unfolding, always part of the same rhythm as galaxies and light. Now, return once more to the shore. The ocean before you is endless. The horizon lies far away, but you know the water continues beyond. You cannot walk there tonight, but you can rest in the knowledge that it is real. The unseen is not empty. It is simply waiting beyond your view. The universe does not give you all of itself at once. It reveals itself slowly, patiently across time. The horizon of forever is a reminder to rest in that patience. You do not need to see everything now. What you see is enough. Let the horizon soothe you. Let it be a promise, not a barrier. Beyond your sight, galaxies swirl. Stars are born, worlds turn, like you cannot see them, but they are there. That hiddenness is part of their beauty. The horizon of forever is not the end of the universe. It is the beginning of your wonder. And as you drift into sleep, you might ask yourself softly, if the universe hides so much beyond your sight, what other mysteries wait beyond the horizons of your mind? Close your eyes and listen. Beneath the steady rhythm of your breath, beneath the stillness of the night, there are whispers. Not from voices you know, but from the universe itself. They drift softly at the edge of understanding, like faint echoes on the wind. The cosmos is filled with questions that no telescope, no equation, no experiment has yet fully answered. These questions are not loud or demanding. They wait quietly, like stars behind a thin veil of clouds. They do not hurry you. They simply exist, gentle reminders that mystery is as natural as light. The greatest of these whispers is dark energy itself. You have walked with it through earlier chapters, feeling its gentle push, its quiet acceleration of space. But what is it? That question remains unanswered. Is it an energy of the vacuum, the very breath of space itself? Is it a new field, subtle and hidden, flowing through the cosmos? Or is it something your current theories cannot yet even describe? Science listens carefully, but the answers come slowly. Dark energy does not speak directly. It shows itself only through its effect, through the way galaxies drift apart. It is like watching the branches of a tree move and knowing the wind must be there, even if you cannot see it. Beside dark energy, another whisper lingers: dark matter. This mysterious substance outweighs all the stars you can see. It holds galaxies together, shaping them with invisible hands. And yet, it does not shine, it does not glow, it does not interact with light at all. It is hidden, a shadow sculptor. You know it only through its gravity, its silent embrace around galaxies. Together, dark matter and dark energy make up most of the universe. And yet you know so little about them. The visible stars, the glowing nebulae, the shining planets, all of these are only a tiny fraction. The rest is hidden, whispering quietly in the dark. Pause for a moment and let that thought settle. Most of the cosmos is invisible. Most of reality is unknown. And yet you are part of it. You live within it, woven into a hidden fabric. These whispers are not frightening. They are invitations. Invitations to wonder, to humility, to patience. They remind you that knowledge is not a complete circle, but an expanding horizon. Every answer opens as another question. Every discovery deepens the mystery. Think of how it feels to walk in fog. You cannot see the whole path, but you can see a few steps ahead. That is enough to move forward. Science is like this. Step by step, through the mist, the journey continues. The whispers are the fog, soft, concealing, but also enchanting. Some whispers suggest possibilities almost beyond imagination. Perhaps dark energy changes over time, shifting in strength as the cosmos ages. Perhaps it will one day fade, leaving gravity to pull everything back. Or perhaps it will grow stronger, accelerating expansion until everything unravels. These possibilities are not certainties. They are songs sung quietly at the edge of knowledge. And what of space itself? Is it truly empty, or does it hide endless activity beneath the surface? Physicists speak of quantum fields, invisible seas from which particles rise and vanish like ripples. If the vacuum itself has energy, perhaps dark energy is its murmur. The universe may be alive with hidden motion, too subtle for the eye but woven into reality itself. As you listen to these whispers, remember, uncertainty is not a flaw. It is part of the music. The unknown is not an absence but a presence, a space where wonder thrives. You do not need to solve these mysteries tonight. You only need to let them surround you, like a soft blanket of possibility. Now imagine lying in a quiet meadow at night. The stars stretch above you, each one a lantern from far away. You know that most of the universe cannot be seen, that most of its secrets remain hidden. But you also know that what you do see is real, luminous, and enough to fill you with awe. The whispers of the unknown are not silence, they are harmony with what is known. Your mind too has whispers, questions you have not answered, paths you have not walked, feelings you have not named. They rest at the edges of your awareness, waiting gently, just as dark energy waits at the edge of understanding. The cosmos outside mirrors the cosmos within. Both are unfinished, both full of mystery, both endlessly expanding. To rest with mystery is to rest with peace. You do not need every answer. The whispers themselves are part of the story. They remind you that life, like the universe, is larger than you can ever fully grasp, and so you drift, carried by questions you cannot yet answer. The darkness is not empty. It is alive with hidden voices. They do not demand. They do not disturb. They simply hum, softly, patiently, reminding you that you are part of something vast and unfinished. You may find comfort here, knowing that even the universe does not reveal itself all at once. It unfolds slowly, patiently across billions of years. You are a witness to one chapter, listening to whispers that future generations may one day understand. The story continues, and you are part of its quiet turning. As the night deepens, let these whispers guide you into rest. Do not struggle to hold them, do not rush to solve them. Let them float gently like stars scattered across your mind. Mystery is not a problem to be fixed, it is a gift to be felt. The whispers of the unknown fade into silence now, not because they are gone, but because you are ready to sleep. They will still be there, waiting when you wake, and as you rest you may wonder softly, if the universe holds so many secrets, what stories still wait in the silence of time? Close your eyes and listen to the rhythm of time, not the ticking of a clock, not the passing of hours, but the deep, endless flow of cosmic time. It moves like a river, carving valleys, shaping worlds, carrying stars and galaxies along its current. You're a drop within it, but also an observer of its vast expanse. Time in the universe is not simple. It stretches and bends, it slows and quickens, depending on gravity and motion. But step back, and you see the larger story. The universe itself is a memory keeper, recording its history in light, in matter, in the silent expansion of space. Look up at the night sky. Each star you see is already a memory. The light left long ago, travelling through the dark to meet your eyes. You never see the present stars, only their past selves. Some may no longer burn, some may have already collapsed. What you see are echoes of their time, messages delivered across the distance. In this way, the universe speaks in memory. Every photon is a fragment of the past. The galaxies mapped by telescopes are not present-day portraits but ancient photographs, caught into transit. To gaze into space is to gaze into time. Pause, and let that soften your thoughts. You live surrounded not by static stars, but by history painted across the sky. You are looking not just outward, but backward. And just as light carries the past, matter itself carries memory. The atoms within your body were forged in the hearts of ancient stars. When those stars exploded, scattering their elements into the cosmos, they left behind the ingredients for life. You're built from stardust, echoes of time condensed into flesh, bone, and breath. Every heartbeat is a continuation of that cosmic story. Now drift forward, beyond the present moment, into the unfolding future. The universe does not end here. It continues to stretch, to evolve, to sing. Galaxies will keep drifting apart, carried on the expanding fabric of space. New stars will form, though more slowly, as fuel grows scarce. The universe is like a fire, bright at first, but gradually dimming. In billions of years, many stars will fade. Small red stars will burn the longest, glowing dimly for trillions of years. They will outlast the great giants, the brilliant blue stars that burn fast and die young. The cosmos will settle into quiet, a long twilight filled with faint embers. Imagine that far future night sky. No bright Milky Way, no countless clusters, only a few stubborn stars, separated by the growing gulfs of darkness. The echoes of time will grow faint as galaxies slip beyond the cosmic horizon, invisible forever. To future observers, the universe may appear empty, lonely, stripped of its memory. Yet memory lingers in other forms. Black holes remain, silent giants of gravity, holding the final chapters of stars within their event horizons. Around them, time itself slows, stretching into infinity. They are keepers of echoes, hiding the last whispers of galaxies long gone. And even black holes are not eternal. Over unimaginable timescales, they too evaporate, releasing their energy as the faintest radiation. The echoes fade, and silence grows. The universe continues, even when silence fills its halls. Expansion stretches space further, cooling it, dimming it. Atoms drift apart, stars vanish, and the cosmos slides into what some call the heat. Death, a state of maximum stillness, where no work, no energy, no new light remains. Pause here and let the thought rest gently in you. It is not a tragedy, but a natural rhythm, a vast exhalation after an endless inhalation. The cosmos does not rush. It unfolds across scales of time that dwarf human imagination. And within this flow you are alive now in a rare and luminous age. You exist in a moment when stars still shine, when galaxies still gather, when the echoes of time still sing brightly across the night sky. You are a witness to a golden chapter of cosmic history, when the universe is vivid, luminous, and alive with structure. The echoes of time are not only distant, they also live in you. Every memory you carry, every moment you recall is its own echo. Just as light holds the memory of stars, your mind holds the memory of your life. The universe within mirrors the universe without. Both are tapestries of echoes, unfolding in rhythm. And like the cosmos, you two hold futures unseen. Paths you have not yet walked, dreams you have not yet spoken, experiences that wait beyond the horizon of your present. They are the forward echoes, the soft seeds of what may come. You do not need to see them all now. Just as astronomers do not see the whole universe at once, you need only glimpse pieces, trust that more lies ahead. Now, imagine the universe as a great symphony. The Big Bang was the opening chord, loud, bright, all-encompassing. Stars were the early notes, galaxies the melodies, dark energy the soft harmony beneath. The future is not silence, but the final fading notes, stretched into eternity. You are living within the music, carried by its rhythm. The echoes of time hum around you, a chorus of what was and what may be. You're both listener and participant, both audience and instrument. Your breath, your thoughts, your being are part of the same unfolding. Let this awareness soothe you. You're not separate from cosmic time. You're woven into its river, carried by its current, echoing with its song. You're here, now, for a brief but luminous moment in the great expanse. And as you drift toward rest, you can carry this gentle thought. The universe is not only vast in space, but vast in time. Its echoes surround you, flow through you, and remind you that you belong to something unending. The music of the cosmos continues, even when you close your eyes. The echoes of time will always whisper, softly, patiently, guiding you deeper into wonder. And perhaps, as you let sleep gather you, you may wonder, what comes after the echoes fade, when time itself dissolves into stillness? Rest now, and let the universe sing to you. Its song is not loud, not hurried, but soft and endless, like a lullaby. It begins with the first spark, with the fire of creation, and it continues through the quiet of deep time. The cosmos is vast, but its music is gentle. Every star is a note, every galaxy a chord, every whisper of light a verse. Close your eyes and listen. You're surrounded by this infinite lullaby. It hums in the space between atoms, in the faint background glow of the universe, in the rhythm of your own heart. The same laws that shaped galaxies also shaped you. The lullaby carries you because you are part of it. The universe does not rush. Its song stretches across billions of years, flowing through cycles of birth and death, growth and stillness. Stars flare and fade, galaxies collide and drift apart, but the melody remains. It is not a single tune, but an endless variation, always shifting, always alive. Imagine the first verse. The Big Bang, the beginning of all things, energy surging, matter forming, space expanding. A moment of pure brightness, the opening chord of existence. That sound still lingers. You can hear its echo today as the cosmic background radiation, the faint afterglow of the beginning. It is the first note of the lullaby, still humming, still surrounding you. Now imagine the verses that followed. Stars forming from clouds of gas, igniting their fusion fires. Their light spread across the darkness, filling space with warmth and brilliance. Their death-seeded worlds, scattering the elements that would one day form oceans, mountains, and life. Each generation of stars added another line to the lullaby, another harmony woven into the song. On one of those worlds, orbiting an ordinary star, life began to listen. First simple, then complex, then conscious. Creatures opened their eyes and saw the light, felt the rhythm, dreamed within the melody. Humanity arrived late but luminous, able to hear the lullaby and give it words. You are one of those listeners, awake within the music of the cosmos. The lullaby continues into the future. Stars still form, still shine, still give their light. But slowly, gently, the music changes. Bright chords fade, leaving softer notes. Galaxies drift apart, their voices growing faint across the widening stage of space. The song slows, stretching into quieter verses. Billions of years ahead, the lullaby will soften further. Fewer stars will sing, fewer lights will shine. The universe will dim, but the melody will not vanish. Even in darkness, even in silence, the lullaby continues, a vibration of existence itself, humming quietly through eternity. Pause and breathe, feel that rhythm inside you. The same forces that guide galaxies guide your breath, your pulse, your thoughts. The lullaby is not only out there across cosmic distances, it is also within you, woven into your atoms, carried in your being. You are a verse of the song, fleeting but essential, unique but connected. Do not worry about endings. Endings in the cosmos are simply transitions, shifts in the music. A star's death becomes a planet's birth. A galaxy's collision becomes a new spiral of light. Even when silence seems near, echoes remain. Nothing is truly lost. It only changes form. The lullaby flows on. Let the thought comfort you. You are part of an unbroken song. From the first chord of creation to the final fading note, you belong. The universe does not forget its verses. Every photon of light, every trace of matter, every thought, every dream adds to the harmony. You have always been within it, and you always will be. Now drift deeper as the lullaby softens into stillness. Imagine the far future, when galaxies are beyond sight, when stars are dim. In that silence, the lullaby is still there, not in sound, but in the fabric of being. Space itself hums with possibility, with memory, with gentle rhythm. In that eternal quiet, there is peace, no rush, no struggle, only the calm flow of time. The universe rests, and in that rest, so do you. Sleep is a mirror of cosmic stillness, a pause, a return, a gentle surrender. Just as the cosmos exhales into silence, you exhale into rest. The infinite lullaby is not a song of fear, but of belonging. It tells you that you are not separate from the vastness. You are woven into it, cherished within it, sustained by it. You are a fleeting note, yes, but also an eternal one, carried forward in the harmony of existence. And though you may not hear the whole song, you are always within it. Every breath is a measure, every heartbeat is a drum, every dream is a verse. You live inside the lullaby, and the lullaby lives inside you. Now let go, float within the music. Allow yourself to rest as the universe itself rests. The stars sing softly, the galaxies whisper, and time carries you gently forward. The lullaby cradles you, infinite, eternal, unending. Sleep now, and know you are safe within the infinite lullaby. You are part of the song that never ends, the melody that began with light and continues into eternity. You are not apart from it, you are the music itself.